kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic.
Good morning, ladies and gentlemen. May I have your attention, please? Our session is about to begin. We inform to remain on the screen during the session. We have some announcement before we start the conference today. Referring to general guidelines for the participants set by the committee, please turn off your microphone during the conference. You are allowed to switch your microphone on during the Q&A session. Don't forget to rename your account to the predefined format, so the committee will be easy to identify you. We encourage you to share this event, so please share the online streaming link and picture from the event to your social media, so people will notice that we have very joyful in this morning. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to International Conference of Mathematics, Science, and Education, ICoMaSEdu 2023. This conference is hosted by Faculty of Mathematics and Natural Science of Universitas Negeri Surabaya. I am Anesia Anggun Kinanti as your Master of Ceremony for today's conference on August 12 until 13, 2023. 23. Before we begin this conference today, I would like to convey the warmest greeting to the Rector of Universitas Negeri Surabaya, whom today is represented by the Vice Director of Planning, Development, Partnership, and Technology, Professor Dr. Siti Nuraziza, Dean of Mathematics and Natural Science Faculty of Universitas Negeri Surabaya, Professor Dr. Wasis, Vice Dean of Mathematics and Natural Science Faculty of Universitas Negeri Surabaya, Professor Rosliana Ekawati, and Dr. Siva Indana. The chairperson, Dr. Risalis Diana, our distinguished keynote speaker, and our moderator today. Also, I would like to greet to all the participants joining in this event today. Ladies and gentlemen, the theme conference is Reinforcing Collaborative Research to Promote Innovation and Productivity. We have some distinguished speaker lineup who will share their insight and knowledge on topics today. We hope you'll find it engaging and enlightening. Ladies and gentlemen, please allow me to read the agenda for today. 1 is opening ceremony. 2. Singing Indonesian National Anthem. 3. ICoMaSEdu with conference chairperson. 4. Opening remarks by Vice Rector of Universitas Negeri Surabaya. 5. Keynote speech first session. 6. Break session. 7. Parallel session day 1. 8. Keynote speech second session. And lastly, closing. Don't forget for all the participants kindly to rename using the following format on this meeting. Ladies and gentlemen, we are now in the opening session, that is singing Indonesian National Anthem. For this agenda, I submitted to the committee in charge.
Indonesia
Thank you for your participation. Moving to the session agenda, we are now going to listen to the opening speech delivered by the conference chairperson. Ladies and gentlemen, please welcome Dr. Lisa Lisdiana.
Okay, thank you, MC. So, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable Professor Dr. Siti Nur Azizah, Vice Rector of Universitas Negeri Surabaya. The Honorable Professor Dr. Wasis, Dean of Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. Vice Deans of Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Honorable Keynote Speakers, Professor Satulu Nakasima, Professor Peter van Wilson, Dr. Zoltan Kovac, Professor Sir Martin Polyakov, and Dr. Eko Haryono. Distinguished guests, presenters, and participants of the International Conference of Mathematics, Science, and Education 2023. Welcome to our virtual ICoMaSEdu 2023. Ladies and gentlemen, the International Conference of Mathematics, Science, and Education is the transformation of Mathematics, Informatics, Science, and Education International Conference, or MISAICS, annually organized by the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. This conference aims to disseminate and discuss recent research findings in the field of mathematics, natural sciences, and education, as well as to encourage the participants to launch collaborative research projects. The theme of this year's conference is reinforcing collaborative research in mathematics, science, and education to promote innovation and also productivity. This conference provides unlimited opportunities for academics, students, postgraduate students, researchers, and also practitioners to share knowledge, exchange ideas, collaborate, and present research findings in the field of mathematics, biology, physics, chemistry, mathematics education, and also science education. ICoMaSEdu 2023 is attended by presenters and participants from overseas and in Indonesia. After the plenary session, the presenters will present their findings in the parallel session based on their research field. Hopefully, this session will be a chance for scientific sharing as well as building future networking. Ladies and gentlemen, we should acknowledge that this conference will not possible without the immense support and help from those who give their all-out effort and hard working. So, I'm very grateful to the organizing and scientific committee for their amazing work to support this conference. Finally, we wish you all a great and fruitful conference. Thank you.
Thank you, Dr. Lisa Lisdiana, for the amazing opening. Excellencies, distinguished ladies and gentlemen, now we are going to process the next agenda, the opening remarks delivered by Vice Rector of Planning, Development, Partnership, and Technology. We also would like to request to the Vice Director of Universitas Negeri Surabaya to officially open the International Conference of Mathematics, Science, and Education 2023. Ladies and gentlemen, please welcome Professor Dr. Siti Nur Azizah.
Okay, thank you very much. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. the Honorable Dean, Faculty of MIPA, Professor Wasis, and Vice Dean, and especially the Honorable Keynote Speaker, Prof. Satoru Nakashima, Dr. Zoltan Kovacs, Dr. Eko Haryono, MPD, Professor Dr. Peter C. Van Welzen, and Professor C. Martin Waliakov. Dear guests, presenters, and participants of the International Conference of Mathematics, Science, and Education 2023. On behalf of the Rector of UNESA, we begin by expressing gratitude to Allah Subhanahu wa Ta'ala for granting us this blessed opportunity to convene and exchange ideas at this significant conference. It is my pleasure as the Rector of Universitas Negeri Surabaya to extend a warm welcome to all attendees, but from abroad and within Indonesia, to engage in the International Conference of Mathematics, Science, and Education 2023. Ladies and gentlemen, predicting the future is like a game of uncertainty, requiring the brightest and most daring thoughts. Even today, we change are taking place very quickly and massively, inspired by the push of science and technology, or by the pull of the global health crisis. It is very difficult to find precise and accurate predictions. At this point, effort to solve various life problems require the role and synergy of researchers around the world to produce faster innovation and higher productivity, as a form of active contribution to achieving the 2030 Sustainable Development Goals. Ladies and gentlemen, inspired by the spirit of Sustainable Development Goals, the ICoMaSEdu 2023 brings the theme reinforcing collaborative research in mathematics, science, and education to promote innovation and productivity. We do hope that this conference will be a platform for the researchers, educators, and the practitioners in mathematics, informatics, science, and education, facilitating the exchange of novel scientific concepts grounded in cutting-edge research. Your contribution will serve as a blueprint steering us toward a better and more sustainable future for the current and forthcoming generation. Ladies and gentlemen, we extend our gratitude to the institution, sponsors, dedicated organizing and scientific committee members, and all participants who have contributed to the realization and success of this conference. Wishing you a productive and prosperous conference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Professor Dr. Nur Aziza, for opening remarks. Before we move to the keynote speech first session, I would like to invite you to all participants to turn on the camera for the photo session. Please hold a moment so that the committee will take the screenshot, and please give your best pose. We have 5 spaces. Now for the first space, in 1 and 2 and 3. For the second page, in 1, 2, and 3. Now let's move to the next slide, the third slide, in 1, 2, and 3. Now for the fourth slide, 1, 2, and 3. And for the first slate, for the last speech, please, 1, 2, and 3. Okay, that was the last one. Thank you. This documentation session is already over. Thank you so much for your best pose. Ladies and gentlemen, now it's time for us to attend the first keynote speech session by Professor Satoru Nakashima from Hiroshima University and will be hosted by Dr. Heri Wijayanto. Dr. Heri Wijayanto is from Chemistry Department of Universitas Negeri Surabaya, and his area of expertise is inorganic chemistry. Ladies and gentlemen, please welcome Dr. Heri Wijayanto.
Okay, thank you so much, Anesia, for the introduction. Good morning, everyone, or good afternoon, good evening, depending where you're joining us. So once again, welcome to the International Conference of Mathematics, Science, and Education, or ICoMaSEdu 2023, led by Faculty of Mathematics and Natural Science of Universitas Negeri Surabaya. So I'm Heri Wijayanto, serving as a moderator from Department of Chemistry from Universitas Negeri Surabaya. So I become the moderator for this session, particularly in the first session. So in this session, we will have two keynote speakers. The first speaker is Professor Satoru Nakashima from Hiroshima University in Japan, and the second one is Dr. Eko Haryono from Universitas Negeri Surabaya. Before that, for vice rector, please, if you have any agenda or schedule, you can leave from the Zoom, or if you would like to join this conference until the end, that's also welcome. Thank you so much.
Thank you. I promise to leave. Thank you very much.
Okay, thank you so much, Vice Rector of Professor Siti. Okay, thank you so much. Now, Professor Nakashima is already here. Let me send a greeting to Professor Nakashima. Ohayo gozaimasu, Sensei.
Ohayou gozaimasu.
Ohayo gozaimasu.
Good
Good morning. Yeah, Sashiburi. Long time no see. How are you? How are you today, Sensei?
I'm fine, thank you.
Yeah, it's been
Very good.
yeah. Thank you. That's good.
Thank you.
That's nice to hear that. So it's been almost a year since I graduated from Hiroshima University, especially from your laboratory. So for the audience, actually, Nakashima Sensei was my supervisor during my master and doctoral program in Japan. So thank you so much, Sensei, for accepting our invitation to become one of the keynote speakers.
So, it's my pleasure. Thank you.
Yeah, thank you so much, Sensei. So, okay, Sensei, let me introduce you to the audience by reading your CV. So, Professor Satoru Nakashima is a professor at the chemistry program from Graduate School of Advanced Science and Engineering, Hiroshima University, and he got master and doctoral degree from Tokyo Metropolitan University. He started his academic career first at the RIKEN as a research fellow, one of the best research institute in Japan. Then he became a professor at Hiroshima University since 2017 until now. He is also now serving as the president of Japanese of Radiation Safety Management, and his area of expertise is about Mossbauer spectroscopy, and then nanoparticles, spin crossover phenomenon, and so on. So, of course, he also published so many papers, about 150 scientific papers. That's great. That's all oh yeah, for as I know, he is one of the Japanese scientists who have a specialization on multiple spectroscopy, which is the topic he would derive today. So that's all the introduction from Nakashima Sensei. So before we get started to hear presentation from Nakashima Sensei, I would like to remind you, Sensei, that you will have 3 minutes for talk, then continue to Q&A session for 15 minutes. And for the audience in the Q&A session, you can ask directly to the keynote speaker by pushing raise hand button in Zoom, or you can write it down in the chat box. You can either write it in English or in Indonesia. I will translate it for you. Okay, Professor Nakashima, time is yours. Having a 40 minutes presentation before we come to the discussion. So, Sensei.
Okay. Please wait. I would have, okay.
Okay. Yeah, waiting.
Sorry.
Okay,
Can you see?
Yeah,
Okay.
I can see. Yes.
Okay. My name is Nakashima from Hiroshima University. So first of all, I would like to thank organizers, especially Dr. Lisa Diana and also Dr. Perry Wijant. I'm very happy to talk here today. The title of my talk is Mossbauer spectroscopy and its application to the chemical science. So this shows the contents of my talk today. First, I would like to show Mossbauer spectroscopy briefly, and then I would like to talk the application of Mossbauer spectroscopy to the chemical science. There are 5 topics. One is mixed valence state. Mixed valence complex has a unique character, so I would like to show that one. Also, second one is spin crossover phenomenon. Spin state changes depending on temperature and so on. So this means chemical character changes depending on temperature and so on. I would like to show this spin crossover phenomenon second. Third one is Fukushima accident. By using Mossbauer spectroscopy, the chemical character of soils in Fukushima is revealed by Mossbauer spectroscopy. I would like to show that one. Also, we can apply Mossbauer spectra to magnetic materials. So Mossbauer spectra shows magnetic splitting. So by using this, so we can study magnetic behavior of the samples. And 5 topic is delta R over R. R is the nuclear radius. Nuclear radius changes from ground state to excited state. The difference delta R. I would like to discuss such difference by using Mossbauer spectra. This is the content. Maybe you know, I would like to show the first, radiation. There are several types of radiation. Wait a moment. Sorry, wait a moment. So, for example, alpha ray is helium nuclei. Also, beta ray is first electron or first positron. So these are particles carrying charge. Also, neutron ray is also radiation. This is neutron. And this is also particle, but this does not have charge. And X-ray and gamma ray are also radiation. These are electromagnetic ray from atom or nucleus. X-ray is from atom. Gamma ray is from nucleus. There are several types of radiation. If we use radiation, so we can see many things. For example, you can see cylinder like this, but you cannot see inside of the cylinder. But if we irradiate gamma ray to this one, so we can see inside of a cylinder because transmittance is different among materials. So we can see inside this cylinder by using radiation. So radiation is very useful to know science or to know chemistry or something like that. So first, I would have shown Mossbauer spectroscopy. This is the resonance of nuclear gamma ray. First, I would have shown resonance of light. This is sodium delay. Sodium delay shows yellow color. So yellow, this shows yellow color if the same atom is here. So this one absorbs this yellow color. So this is resonance of light. Gamma ray is also electromagnetic wave. But it was so difficult to observe resonance because the energy of gamma ray is very huge. For example, in this case, 14 kiloelectron volt. Energy is 14 kiloelectron volt. But the energy of atom is only 2.1 electron volt. So energy is very different. So if this particle emits gamma ray, so it shows recoil. So this is action-reaction system. So recoil energy is also big in the gamma ray. So by relative larger recoil energy, so energy decreases. Gamma ray energy decreases. So it's not easy to go up from here to excited state. So this is the reason why it is very difficult to observe gamma ray resonance. But Mossbauer at that time, he was graduate student. He tried to observe resonance of gamma ray resonance, but he decreased the temperature. He actually observed. So you can see this picture. So this is a board. So we shoot a cannon from here to this board. This board are on the lake, but this cannon energy is very large. So recoil energy also very large. So this cannon cannot reach this board. But he decreased the temperature. This means the lake was frozen. So in this case, recoil energy becomes zero. So absorption, that is resonance, was observed. This is the principle of gamma ray resonance. We call this recoilless nuclear gamma ray resonance, or this is Mossbauer effect. This resonance energy changes depending on chemical state. So this shows, I would show first ICoMaSEdu shift. So by this ICoMaSEdu shift, resonance energy will be shifted. By using this shift, we can understand how the chemical state is. So there are several types of electrons: S electron, P electron, D electron, F electron. There are several types of electrons. Only S electron can stay at the nuclear position. Other electrons, P electrons, D electrons, and F electrons cannot stay at the nuclear position. These P electron, D electron act as shielding. If the P electron is much, so shielding, it works as shielding. So S electrons decrease, or P electrons is small. In that case, shielding is small. So there are much S electrons. If the electron is much, so interaction between nucleus and electrons is very effectively. So such difference appears as a shift of resonance. By measuring such a shift, so we can understand for example, oxidation state, for the iron 2 or iron 3 or iron 0. So we can obtain such information. Next shows, I would like to show quadruple splitting. This shows the shape of nucleus. So the shape of nucleus is drawn by using nuclear spin number. If this number is 0, so the shape is sphere. And if the nuclear spin number is 1/2, the shape is sphere and it rotates. So this becomes spin. And so if this spin number is 1 or larger than 1, so the sphere deforms like this or like this. This is spin axis. So this deformation, so is drawn like this. Electric quadrupole moment is larger than 0. So that is positive. So the shape is like this. If this moment is negative, the shape is like this. We consider positive Q here. So we consider positive Q, and so the shape is like this. Such shape, such nucleus has two forms. One is declining, raining down like this. One is standing. If the electron distribution is symmetric, there is no problem. But the shape is like this. So if electron is much in this direction, so in this there is much electron here and here. So the distance from here to here becomes close. So this state becomes relatively stabilized. On the other hand, in this nucleus, the distance is relatively far. So this state relatively destabilized. These two states will be split like this and this one. So there are two transitions from here to here and from here to here. So there is a doublet. They will split. By this split, so we can understand how the electron distribution around nucleus. We can judge such thing. And also this spin, this left-hand spin and right-hand spin is usually has the same energy, but this nucleus in the magnetic field, this spin and this spin will be split. So this is Zeeman splitting. And from here to ground state, this is the condition, delta I equal 1 or M like this. So from this selection rule, there are 6 transitions. So we can six spectrum. We call this spec step. By this sixth step, we can understand magnetic field. So we can apply this to magnetic material. So by using such ICoMaSEdu, quadruple splitting, also magnetic splitting, so we can understand the chemical state or magnetic state. This shows Mossberg gamma rays. In the case of iron 57, we use cobalt 57. Cobalt 57 shows EC decay. EC means electron capture decay. So this goes to excited state of iron 57. This state goes down to first excited state, and then this goes down to ground state. So 14.4 kiloelectron volt energy will be emitted. This is Mossberg gamma ray. We use this gamma ray for gamma ray resonance. So this is one typical example of application to the chemical sciences. Maybe you know this is ferrous solution. To this ferrous solution, if you add potassium ferricyanide, you add this one. So you will obtain Tambus blue. Also, if you this is ferric solution. To this ferric solution, if you add potassium ferrocyanide, we obtain Prussian blue. These are very strong blue. This shows very strong blue colors. These blue colors is used. You can see this is bullet train in Japan. So this blue color is from this Prussian blue. So by mixing 2+ and 3+, 2+ and 3+, so new character appears. New character such as blue color appears. This is very interesting. If we measure this sample using Mossbauer spectroscopy, so these are the spectra. These spectra are the same to each other. This is iron 3, and this singlet is iron 2. So there are iron 3 and iron 2. The structure is like this, this shows Tambus blue and Prussian blues are same to each other. Also, they show new character such as blue color. So this is one typical example of Mossbauer spectroscopy to the chemical science. So next, I would like to show the mixed balanced state of binuclear ferrocene derivatives. This is ferrocene. Iron 2 is sandwiched with cyclopentadiene rings. This is iron 2. This ferrocene is easily oxidized by using iodine. So this becomes iron 3. So if we connect this iron to this ferrocene and this ferrocenium ion, connect this one. So this becomes binuclear ferrocenes, and this is mixed valence state. This has iron 2 and iron 3. So iron 2 has excess electron compared with iron 3. So if the electron transfer is slow, so iron 2, iron 3 are observed independently. But the transfer rate is very fast. So it looks like 2.5 balance state. So this shows only 2.5 balance state. This is average balance state. So we can distinguish this state and this state by using Mossbauer spectra. So these are very old data of my data. So I want to show the mixed balance state of dibutyl biferrocene triiodide. This is we introduce butyl group here. So we obtain mixed balance state of this one, and we synthesize this one, and we decrystallize again and again. We obtain two crystals. One is needle-like crystals, the other is plate-like crystals. Also, we succeeded in X-ray structural analysis. Needle-like crystals is like the structure is like this, and the structure of plate-like crystals like this. So crystal structure is different. Also, we measure the samples. So you can see these are the spectra of needle-like crystals. So you can see two doublets, outer doublets from iron 2, inner doublets from iron 3. So two doublets, iron 3 and iron 2, are observed at lower temperature and higher temperature. On the other hand, in the case of plate-like crystals, so you can see two doublets at a low temperature. But if we measure at room temperature, so only one doublet appears. So valence detrapping occurred in this plate-like crystals. So balance state, mixed balance state, depends on crystal structure. This is first point. Next, I would like to show the result of bis 2-phenylbutyl biferrocene pentaldehyd. So this is phenyl. the position is 2. This is a butyl group. So you can see this carbon is asymmetric carbon. So this asymmetric carbon, so please imagine, so R or there is RS, there are two conformers, R or S. And so please imagine, if R conformer moves by using inversion center, R moves to S. So this conformer has inversion center. So if we introduce these two phenyl butyl derivatives here, there are 3 conformers. That is RS conformer. This has inversion center here. And also R conformer and also SS conformer. These two never have inversion center here. But this SS conformer and other conformer have a relation having mirror image like this. So there are 3 conformers: RS conformer, SS conformer, RR conformer. By looking at this asymmetric carbon, RS, we synthesize these complexes, and so we oxidize using iodine. So counter anion is I5. This is pentaiodide. So pentaiodide forms like this, connect like this. Pentaiodide forms symmetric vacancy. We introduced RS conformer, SS conformer, RR conformer to here. So you can see, we measured most of our spectra. You can see the spectra. So only, in the case of RS conformer, only one doublet is observed. Only average balance state, only 2.5 balance state observed in the case of this one. On the other hand, RR conformer or SS conformer shows 2 doublets, but 2 doublets are very close to each other. But there are 2 doublets at lower temperature and higher temperature. So in this case, these conformers never show average balance state. So symmetry is very important to the mixed valence state. Next shows the symmetry change and balance detrapping for diacetyl triiodide. So this is the result of most spectra. Outer doublet is iron 2, inner doublet is iron 3. By increasing temperature, 2 doublets approaches to become average balance state. So balance detrapping occurs. And we also measured IR spectrum, but wave number is very low, from about 40 wave number to about 250 wave number. This is triiodide anion. This triiodide anion has three vibrations: nu1, nu2, and nu3. Nu1 is symmetric stretching. Nu2 is deformation vibration. Nu3 is anti-symmetric vibration. If the symmetry is not so good, three absorbance is observed. But by increasing temperature, if the symmetry becomes good, so symmetric vibration becomes IR negative, IR inactive. So this nu1 vibration disappears because a symmetry becomes better. So by comparing this IR and this MOSFET spectra, so symmetry of monocation and also symmetry of anion becomes better by increasing temperature. So symmetry change is very important to know the mixed balance state. This is very interesting result. So these are the results of mixed valence state. And next, I would like to move to spin crossover phenomenon. So iron 2 complex has 6 d electrons. If ligand field large, 6 electrons distribute like this. So total spin is 0. This is diamagnetism. We call this low spin state. But this spin state, this ligand field splitting is small. Electron distributes like this. So total spin becomes 2. This is paramagnetism. So we call this high spin state. If the ligand field strength is intermediate, the spin state changes depending on temperature, pressure, and light illumination. By changing spin, so chemical character or physical character changes because this has no spin, this has spin state. So chemical state changes. Such change can be studied, can be observed by using Mossberg spectra. In the case of high spin state, isomer shift is relatively high, and doublet is observed. On the other hand, in this low spin state, isomer shift is relatively small, and usually this shows singlet. So it's easy to judge by using Mossberg spectra the spin state. So we studied such spin crossover phenomenon. We studied assembled ion complexes. We used bridging ligand to form as polymers, assembled ion complexes. By using such bridging ligand, the structure becomes porous. Our interest is like this. These are porous assembled complexes. So in that case, there is a cavity. So we can introduce gas molecules or dissolve gas molecules. So on and off. So by introducing gas molecules or dissolving molecules, we want to control physical character such as spin state. So and also the shape, size, and function of this cavity become designable. So I want to show the first example of spin crossover system. So we used the bridging ligand, this one, BPA, this pyridyl ethane. This is ethane. This is bridging ligand. And also NCX, this is anionic ligand. So we use this one. In this case, without gas molecule, we obtain the sample, and also we measure the Mossberg spectra. So you can see isomer shift is relatively large, and also doublet is observed. So this shows high spin state. This does not show temperature dependence. And also we introduce gas molecules. For example, biphenyl, we introduce gas molecules. And so we obtain the crystals. And we measured Mossberg spectra. So you can see at room temperature, isomer shift is large, and so doublet is observed. So this is high spin state. But we measured at low temperature, so isomer shift decreases, and so singlet was observed. So this is low spin state. So in this case, without gas molecule, only high spin state observed. And in this case, we introduce gas molecule, biphenyl. So spin crossover phenomenon observed. This is the first example. This is the second example. We introduced BPP. BPP is bispyridyl propane. So we added one more methylene here. So we obtained complexes. So anionic ligand is like NCX. So NCS, NCSC, NCBS3. So Mossberg spectra, we measured Mossberg spectra. You can see at room temperature, high spin state. By decreasing temperature, we observed low spin state. And we absorbed gas molecule, benzene. We absorbed benzene here. In this case, isomer shift is relatively large, and so doublet was observed. So this shows high spin state, and this does not change. Spin state does not change. So in this case, also by introducing guest molecule, the spin crossover phenomenon changed. So on-off was obtained. But there was problem. There was problem. In the BPA complex, first one, in the BPA complex, SCO off, only high spin state was observed. One gas molecule, gas-free complexes. SCO appears, SCO becomes on when including gas molecule. On the other hand, in BPP complexes, SCO, spin crossover, appeared, becomes on when gas-free complex. But we introduce gas molecules, SCO becomes off. These are opposite. These are opposite. So what is the role of gas molecule? What determines the spin state in these CP means coordination polymers, that is assembled complexes. But I want to know the role of gas molecule. So actually, we investigated the X-ray structure. And so we checked the literature. The local structure, we checked local structure. There are 3 types local structures. So you can see these are pyridine, and these are anionic ligands. So if we look at pyridine, so this shows propeller type, and this shows you can see this pyridine and this pyridine are parallel. So this is parallel type, and this is propeller type, but this is distorted. So there are 3 types of local structure, and propeller structure tends to show spin crossover. On the other hand, propeller type or distorted propeller type tend to not show SCO. This is SCO off. So you can imagine the local structure is very nice. It's easy, very good. But in this case, parallel type or distorted type is a little bit crowded here, and also crowded here. And also ion nitrogen distance. In the case of a high spin state, this distance is about 2.1 angstrom. In the low spin state, it is 1.9 angstrom. To become low spin state, the distance shrinks about 0.2 angstrom. So in this propeller structure, it's relatively easy to approach this nitrogen to ion. On the other hand, in this parallel type, distorted propeller type, it is very hard to approach. That's the reason why propeller type shows spin crossover phenomenon. On the other hand, parallel structure, distorted propeller type tend to show only high spin state. We simulated such chain. So you can see this is propeller type structure. We fixed this angle 60 degree, and also we rotate this pyridine. So you can see this angle is 30 degree. We rotated 2 pyridine like this. This angle is 40, and also we rotated this one. This angle becomes 50, and also we rotated. This angle becomes 60. So propeller type structure changes to distorted propeller structure. And so we perform DFT calculation. We obtain potential energy surface. So at propeller type structure shows like this. Low spin state becomes global minimum. But by deforming propeller structure, low spin state more destabilized because static hindrance effect more stabilized. So deformed propeller type structure. So high spin state becomes global minimum. So in this case, propeller type this is at low temperature, low spin state. But by increasing temperature, this becomes high spin state. But in distorted propeller type, so this state is global minimum. So at lower temperature and a higher temperature, only high spin state was observed. So this is the reason why SCO phenomenon occurs or not. So next topic is Fukushima accident. So on March 2011, Fukushima accident occurred. So Station 137 and also such radioactive materials dispersed in the environment. So this becomes external exposure, or if we eat contaminated rice or something like that, so it becomes internal exposure. So the migration of radioactive materials is very important in environment or from soil to rice plant. So the migration is very important. So we studied migration. This is two examples. We studied the migration station 137. So this is Fukushima. Fukushima is here, around here. So station 137 moved to, for example, Niigata Prefecture. And then this station 137 moved with sea current like this. So we gathered sea sediment and we measured radioactivity. So we found migration session 137 via sea current. And also we investigate the horizontal migration from catchment area to lake. So we studied such migration. Also, we studied contaminated rice. So there are 4 rice fields. They are close to each other. So field A, B, C, D. They use the water from this pond. These fields are close to each other, but only field B showed contaminated rice. Field A, field C, field D did not show contaminated rice. We also measured potassium 40. So potassium concentration of field was low in this field B. You know, potassium and cesium are alkaline metals. So the chemical character are very similar to each other. So they compete to each other. If the potassium is much, so cesium will not be absorbed so much. But potassium is not so much, it's less. So cesium tends to be absorbed to the plant. So this is the reason why field B shows the relatively larger contaminated rice. So the result is similar to the reported result. We investigate other factors. We check the soil grain size distribution. So if small size silt and clay increase, the transfer factor means how much cesium migrate from soil to rice grain. So if the small size silt and clay increases, so transfer factor decreases. On the other hand, large particle medium sand increases, the transfer factor increases. So grain size, solid grain size also important. This is other factor. And also we measured MOSFET spectra of the soils. You know, soils include iron. And so if we measure MOSFET spectra, it's easy to distinguish iron 2 and iron 3. It's easy to distinguish. we measure the relative area, ratio of iron 2. So you can see the relative area for B samples. So it's very relatively small. The ratio of iron 2 is low for field B. So our assumption is like this. Potassium is more dissolved in the reductive atmosphere. So field B was oxidative atmosphere. And on the other hand, field A, field C, field D were reductive atmosphere. So potassium is more dissolved in the reductive atmosphere. So in that case, cesium cannot be absorbed to the right plan. On the other hand, in the oxidative atmosphere, potassium is not so much dissolved. In that case, cesium will be absorbed. So this is also this is our assumption. So oxidation state that is oxidative or reductive of soils is also important to show or not show contaminated rice or not. So next topic is magnetic materials. So as I talked, if magnetic interaction, if there is magnetic interaction, so this shows sex step. So by this sex step, we know magnetic field. So this is an example of hematite. Hematite is alpha Fe2O3. Hematite at lower temperature, this spin and this spin shows up and shows opposite direction. This is anti-ferromagnetism. In this case, but at higher temperature, this spin a little bit declined like this. So total spin tends to like this, becomes like this. This becomes weak ferromagnetism. These two states changes. We call this Morin transition. So in this case, in this sex step, this peak and this peak difference, and this peak and this peak difference, we compare this one. From here to here, we subtract. So this becomes delta EQ. So in this case, delta EQ becomes plus 0.4 millimeter per second. This is quadrop splitting. And in the case of weak ferromagnetism, we subtract from here to here. So this becomes this becomes negative, minus 0.2 millimeter per second. This shows weak ferromagnetism. So we can judge Morin transition occurred or not by looking at this sign. So we introduced niobium to this hematite. So we calcined the sample at 500, 600, and 700 Celsius. The sample calcined at 500. 500. This is maghemite. Maghemite is magnetic material. It's attached to a magnet, and so this shows. This one shows hematite, but this is attached to magnet. So this is due to niobium has no spin. So this becomes ferromagnetic-like structure. So this is attached to magnet, and the sample calcium 700 Celsius. This is ferromagnetic. So this is weak ferromagnetic character. So this sample does not attach to this one. And so we measure this sample here. So red one is iron niobium 04. Green one shows hematite. We decrease the temperature. So we found two sex steps. blue one shows anti-ferromagnetism, and green one shows weak ferromagnetism. So in this case, molding transition, so incomplete molding transition, this phenomenon is very rare. We found such very rare phenomena. And also this niobium introduced hematite. So we applied these samples as catalyst. So you can see blue color. This is from methylene blue. We irradiated. We added hematite here. We irradiated. So photophantom reaction occurs. So methylene blue, harmful methylene blue, decomposed by this photophantom reaction. But we add niobium here. So the rate becomes very fast. So this is very interesting. So this is the result of magnetic samples. Hey-san, how many times?
Okay, so actually it's already 40 minutes, Sensei.
Okay, I'll show very short.
Okay, okay,
That's
no
I'm sorry.
Okay.
I'm sorry. Next one, this is last topic. R means the radius of nucleus. So how the radius of nucleus changes from ground state to excited state. So this shows isomer shift. Isomer shift is drawn like this. Isomer shift depends on delta over R, and so electron density at nuclear position. So this means if we measure isomer shift, and if we calculate electron density at nuclear position, we can get delta R over R. This is nuclear data for MOSFET transition. So in the case of iron 57, this is the delta R over R times 10 to the 4th. So this means this negative value means nucleus shrinks from going to ground state to excited state. And in the case of Lutetium-99, this value means positive. So this means expands. But in the case of Osmium-189, there is no report. Nobody knows it expands or shrinks. We calculated electron density at nuclear position in the case of ruthenium and osmium. So this is a reported isomer shift value. We calculate electron density at nuclear position by these are different functionals. In the case of Lutetium-99, so if the electron density increases, isomer shift increases. On the other hand, in the case of Osmium-189, if the electron density increases, but the electron density isomer shift decreases, this is opposite result. This means the sign is different between the two. So by using this relation, we calculate delta R over R. So in the case of Lutetium-99, so we obtain positive value. So this means nucleus expands by this MOSFET transition. On the other hand, Osmium-189 shows minus value. This means shrinks by this MOSFET transition. So we can obtain such nuclear data, very important data, by using MOSFET isomer shift and also by calculating electron density. So we can judge nucleus expands or shrinks, that is contraction, by measuring MOSFET isomer data and also electron density calculation. So by using MOSFET resonance, so we can judge mixed valence state or spin state, such as these are very important for chemistry, and also we can chase the move of radioactive materials, and so we can understand the small change of expand or shrink of nucleus. So the shift is only 10 to the minus 19th meter, and also the movement of cesium-137 is about 10 to the 6th meter. Our research target or our research motto is by using radiation, so we can understand such very different distance change. So this is our group. These results were obtained from our group. I would have thanked these groups. And also, I'm sorry, I used much time. So thank you for your attention. That's all.
Yeah, okay. Thank you so much, Sensei, for your nice presentation. I really enjoy your presentation of your research. It's very insightful presentation, Sensei. And actually, it reminds me about the hard work of conducting research in Japan, especially. Okay, now we are in the Q&A session.
Yes.
So please, for participants, if you have any question or comments or thoughts, you can directly ask to the Professor Nakashima by raising your hand or write it down your question in the chat box, or even for audience from YouTube, watching from YouTube, you can also write your question in the comment. So our committee will help. Nakashima Sensei,
Hi.
may I have a question for you?
Yes.
Yeah, about the Fukushima accident, where the nuclear power plant, namely Fukushima Daiichi nuclear power plant, had a hydrogen explosion due to the tsunami and earthquake in 2011.
Yes.
Then spreading amount of radioactive material, especially in cesium 137.
Yes.
So my question is that, do you think that iron in the soil will also affect the absorption competition with the cesium to the plant or paddy? Because the plant, as you know, that absorbing also any metal from the soil, right? So is there any contribution from the iron itself?
I used iron just to know the atmosphere of soil. Is this reductive or oxidative condition? But we measure to know that. But in my impression, I also, by using the intensity of the absorption, so we can judge how much iron in soils or not, or soil. This is just my feeling. There's a possibility to become catalyst. I'm not so sure, but catalyst. Iron supports the absorption or disturbs the absorption, cesium or potassium from soil to rice plant. But this is my assumption. I'm not so sure. So we use MOSFET spectra to know oxidative or reductive atmosphere. This is one point, and also this is we can judge this one, and also this is my assumption. There's a possibility to become a like catalyst of absorption of cesium or potassium, but I'm not so sure this assumption.
Yeah, that's very interesting, Sensei. You said that the iron also probably can be a catalyst to support the absorption of cesium or potassium. And
that's a possibility.
Yeah, possibility. So do you think that you can prove your assumption by, I don't know, maybe you can do any research or measuring something? Is it possible?
in not in natural samples, by practicing by ourselves, and add ions or add cesium or add potassium to the field in private field. So there's the possibility to
Okay.
check such things.
Okay.
Okay.
I don't know, maybe that would be very nice,
Mm.
interesting topic for the next research, maybe. Okay. I saw there's a participant from Dr. Fas. So would you like to deliver your question to Professor Nakashima directly?
Okay, thank you so much, Mr. Heri Wijayanto. First of all, I would like to say thank you to Professor Nakashima for your presentation. I think I got some new insights in this presentation, and then I would like to connect with my current research. Especially, I would like to focus with the mesh-bore spectroscopy. My question is, if we have some metallo-supramolecular coordination is contained with some ion inside, so how sensitive the mesh-bore spectroscopy to detect some metal ion inside? This is the first one. And then second one is, it can be possible to describe about interactions between metal coordination inside the structure. Okay.
About first question. So most of the spectrum is very sensitive. It's easy to, for example, judge ion 2 or ion 3 or ion 4 and ion 0. So it's very sensitive to such oxidation state, and also high spin and low spin or intermediate state. It's very sensitive to such spin state. And also in the same oxidation state, for example, quadruple splitting doublet is also changes even in the same even in the similar structure. It's very sensitive. So maybe most of spectroscopy is very sensitive to such things. This is my answer to your first question. But I'm sorry, I couldn't follow your second question.
Yeah, second question about the interactions between the metal ion inside the structure. For example, if we have some metal supramolecular coordinations, which is contained with the several structure inside. So I would like to describe about some interaction, for example, hydrogen bonding interactions maybe inside. Is it can be possible to detect using the mesh-bore spectroscopy?
I think so. If you obtain the spectrum, but if the hydrogen interaction is changed, for example, maybe I imagine small changes, small isomer shift or small quadruple splitting change will appear. But it depends on the situation. But I think it's very sensitive to such QS or IS. I mean, if the interaction changes, the electron density, electron distribution around ion nucleus will be changed. So most of our spectrum will be shifted, or the splitting also will be changed.
Okay, I get it. Yeah.
I'm sorry, it's okay.
Yeah, I got it. I got it, Prof. But maybe my consider is about the amounts of metal inside the structure is pretty small. So I'm afraid it can be doesn't mention about the interaction inside the structure. That's my concerns right now.
So you mean the amount of ion You
Yeah,
are discussing about amount of iron.
yeah, the amount of iron is pretty small.
It needs so
So-
I want to ask you are asking if the iron amount is small, is it possible to measure? Is this your question?
Yep.
So, okay, we use iron 57. We use iron 57, but iron natural abundance of iron 57 is small, about 2%. So iron 56 is much. Iron 57. This is also stable isotope. Is only about 2%. So you can enrich iron 57 to your sample. So it becomes easier to measure Mossberg spectra. We can do such enrichment of iron 57. Is it okay? Is your answer?
Yeah. Thank you, Professor. I think it's clear for me. Perhaps in the future, I have a chance to measure my sample by Mossberg spectroscopy.
Okay.
Okay, thank you.
I can measure. Okay.
Yeah. Thank you so much, Dr. Fasi. Yeah, actually, Nakashima Sensei is open for collaboration, maybe.
Oh, yes, it's open.
Of course, yeah. So as I know, during the measurement of Mossberg spectroscopy, it's possible to measure small amount of sample, but it takes more time, maybe. Yep.
Yes, that's right.
Okay. Yeah, Sensei. Yeah. If you have more sample, it will take
It's a little bit easier.
yeah, easier. But if you have a small amount of sample, that also would be okay, but it takes time to get the result.
And also,
Uh-huh.
we collimate. Do you know collimate? So we cover red only. We collimate gamma rays, the small region. So maybe we can measure small sample by collimating. Okay.
Okay. Thank you so much, Sensei. So any question from other? Okay. Okay. The time it's. I think that's the end of our Q&A session, Sensei. Thank you so much.
Thank you.
Thank you so much for your presentation. So now we are in the end of the first presentation from the keynote speakers. It was very interesting to hear the most powerful equipment from Mossberg spectroscopy, because many things to do, like doing fundamental research for chemical science, not only chemical science itself, but also for physical and as well as the environmental science. It's very detailed and it's a very nice finding, Sensei. We do hope to see more from your research, because this equipment is actually kind of something something new in Indonesia, as I know. Almost no institute or university in Indonesia have it. So thank you again for Professor Nakashima for your time. It's a great honor to have you in this conference. And on behalf of committee, as an appreciation, I would like to present you a certificate of keynote speech. So, excuse me, Sensei, could you please stop sharing your Zoom?
Wait, okay.
Yeah, okay. So we would like to award you a certificate of a keynote speech for committee. Could you help me to show the certificate?
So certificate?
Yeah. This just for appreciation. Yeah. Here it is, the certificate. Maybe we will send you by email or mail.
Thank you very much. It's my pleasure. Okay.
Yeah, thank you so much, Sensei.
Thank you, Heri-san.
Yeah. So, Sensei, I have your time to take a picture of this
Yes,
Zoom?
please.
Yeah, okay. For committee, maybe Anesia, could you please help me?
Okay, thank you. I would like to invite you all the participants again to turn on your camera for further session. Please hold a moment so that the committee will take a screenshot, and please give your the best pose. Now we have the first speech now in 1, 2, and 3. The second page in 1, 2, and 3. The third page in 1, 2, and 3. The fourth page in 1, and 2, and 3. And the last page in 1, 2, and 3. Okay, that was the last one. Thank you. This documentation is already over. I'll return this session to Dr. Heri Wijayanto.
Okay.
Time is yours.
Okay, thank you so much for Anesia, Master of Ceremony. And Professor Nakasima, once again, thank you so much for your time.
It's my pleasure. Thank you very much.
So you may proceed your next agenda, or you can stay in this forum. That's also very welcome. Yeah. So Nakasima Sensei, see you again in the near future, hopefully.
Okay. See you again.
See you again. Thank you so much.
Thank you so
Thank
much.
you so much, Nakashima Sensei.
Thank you.
Okay, now we are moving to the second keynote speaker in the first session. So he is Dr. Eko Haryono. I think he is already here.
Yes, I'm ready.
Yeah, good morning, Dr. Eko.
Good morning, Pak Heri Wijayanto. How are you?
How are you? I'm good. How are you?
Okay, thank you.
Yeah, thank you for coming to our international conference. It's a great honor to have to invite you to have a talk in this conference. So, Dr. Eko, let me introduce you
Okay, please.
to the audience by reading your CV. Okay, Dr. Eko is actually an associate professor in science education in Universitas Negeri Surabaya, and he is actually also the head of study program for master program in science education, Universitas Negeri Surabaya. So before he took master and doctoral study in science education, he got a bachelor degree in physics education. His research is actually about something related to the natural disaster in Indonesia, and also disaster mitigation through education. So he is specialized in volcano and tsunami education and mitigation, and published so many books, so many papers related to that. And recently, if I'm not mistaken, Dr. Eko, his research is focusing on the education of climate change,
Yes, right.
which is his topic for today's presentation.
Yeah.
That would be very interesting because climate change issues are quite old topic actually. As I know, this topic has been raised in 1970s, discussed in Stockholm on the UN conference. Then the most influential climate change action had been taken so far in Kyoto, Japan, namely Kyoto Protocol. That's only what I know. But climate change nowadays still a hot topic. So that would be very interesting to discuss.
Persiapan, Pak.
That's all the introduction from Dr. Eko. Before we get started to hear presentation from you, Dr. Eko, I'd like to remind you again that you will have 40 minutes to talk, then continue to Q&A session for 15 minutes. So, Dr. Eko, time is yours, please.
Okay, thank you, Pak Heri Wijayanto. I try to show you my presentation slides, okay?
Okay, now it's showing. Yeah, that's okay.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Okay,
wabarakatuh.
Bismillah, Alhamdulillah. Thank you very much to all participants, especially for Professor Wasis Semisi, Dean of FMIPA, Professor Roselyn, Vice Dean 1 of FMIPA. Also, special thanks to Bu Lisa Listiana, PhD, ICoMaSEdu Conference Cell, and then all participants. Today, I would like to share with you my experience with many members from Asia Pacific. I have one topic about my presentation today, ATC, a lesson learned to build collaborations about the climate change education in Indonesia. Okay, this becomes special collaborations between UNESA, UP, and also Okayama University. Then I start from my unique phenomenon in our city from Surabaya. Actually, if we try to check from the rainy season for 21 February in 2022, actually, the Surabaya has a hailstone rain. This become terrible conditions in our city. And then we have bad situations in our environment also. Actually, we have big storms, also big accidents on the street. Actually, maybe we have one reason why the hailstone rain happened in Surabaya. We know that the Surabaya is a city in a tropical country, and hailstones very seldom will happen in this area, in this country. And then for the next slide, these are another situation. There are abrasion phenomena in Amurang Beach, South Minahasa, 15 June 2022. This become bad situation to all peoples in there because they have many broke for many buildings. And then we have an equation. What are the correlations with the climate change phenomena? Actually, these only two examples about the climate change impacts in our country. Actually, we have a bad situation now, and then maybe for the next time, if we have not good understandings about the climate change impacts in our situation. And I try to share with you, actually, we have two kind concept, so then we can make difference between climate and weather. Actually, weather is a physical process of the atmosphere, of the state of this, or the state of the atmosphere at a time. Actually, what we can see in our environment, this is a weather. But the climate is not similar with weather. We need a long time about to make conclusion about our weather situation. Start from Canada for 10 years, 100 years, we often call a centennial, until thousands of years, we can call millennial, and or a long time, we often call paleoclimatology. This simple concept to introduce about differences between the climate and weather to our students. Actually, we can make a simple sentence. The climate is what you expect and the weather is what you get. And then I found important information from the compass. Actually, we have warning to the earth. Actually, I found one articles about the climate anomaly and high temperature in the earth. Actually, these notes from the meteorological world, and then they state for the 2022 become higher than before, especially about the temperature. We have 1.15 degrees Celsius, more higher than before, as long as 1850 until 1900. This become terrible information to us because we will get a bad situation in our environment. And then this give a bad situation in our life also. I try to explain why the temperature become good, become important variables in the climate change. Actually, if temperature can change, so meteorological and environmental variables, the change in temperature might cause a change in precipitation for the first one. So we can check from our situation now. Actually, in the rainy seasons, the water's percentage is not more than before. And then about the vegetations might also change in response to temperature and precipitation changes. Yeah, if you have time to see your environment, actually you can comparing trees condition. Yeah, actually they have different situations between now and before. And then there will be changes in the animal and human world in response to these environmental changes. Actually, now we often hear about the anomaly behavior of snakes. Yeah, we often get information that snake come to your home because they get a bad situation in the environment. This become a nice parameter to give conclusions about our situation now. So then our temperature is not good to the life. And then these parameter condition of global warming, actually we have four situations that form the rise of carbon dioxide, and then the rise of glacier area. I'm sorry, the decrease of glacier area, and then I'm sorry, I try to. Okay, the temperature is rise. Start from 0.68, and now in 2022 become 0.85, and then the rise sea level start from 40.9 and now become 102.5. Yeah, it has rise until 151%. This become terrible to our population in coastal area because the rise level for water, I'm sorry, seawater, this become bad situation to our coastal area. Yeah, we will get many building will down in the water. And then, I'm sorry, these some even causes from the climate impact we often call global extreme weather in Argentina, in Peru, Arab Saudi, Pakistan, also Africa Selatan. Maybe you can read from the slide what happened in Argentina, Arab Saudi, Pakistan, Africa, and Peru. And then we have to check in our country. This is situation in our country. Actually, we have similar situation. Our country is try to comparing with others country because we will have drug decision, rainy season, and forest fire, and so on. And then, actually, from all phenomenon, we have big homework how to give knowledge or understandings to our peoples, especially to our students, so they have good understanding of the climate change is important. So we must create to good climate change education to our students. Actually, I try to check from the SDGs, Sustainable Development Goals. Actually, we have 2 points become our responsibility For the first one, how to make a good quality education. Also, we can make a good climate action. This is a good option to us, so then we can prepare our students to face all situations now and next time, especially connected with the climate change impact. For the number 4 of quality education from the SDGs, actually, we can read from the slide concept of education for sustainable development, or ESD. World institution approach is key strategy to scale up education for sustainable development and pedagogy for developing sustainability competencies. Now, we can stop to learning to our students, only give informations about the concept, especially for science education. But we must give opportunity how to our students can imply all topics, all concepts, so they have good skill to get solutions about all problems in them life. This is very important. If we can make connecting with problem solving skills, actually we can ensure for now and next time our students can succeed to respond or challenge come from climate change impact. And then this special orientation to SDGs number 13 about climate action. Actually, these are simple models how to make a good quality education, so then our students have good skills to make a response about the climate change impact. Actually, we can develop an inquiry-based project investigating this statement, those who cause the most damage to the atmosphere should pay for it. Actually, besides he or his students have good understanding about the topic, they also have changed to applications, all context, all contents from the learning result. So they will give good solutions about the climate change. Also, not only this one, but they have a responsibility for the next life. And then this is ASEAN framework of teacher education program for climate education, or RTC. This is honorable me because UNESA, Universitas Negeri Surabaya, become one university from many universities inside. Representation from Indonesia, delegation from Indonesia to participate in the international research. Actually, ATC consists of 9 countries that form Mongolia, Kazakhstan, China, India, Thailand, Malaysia, Philippines, and Japan, and Indonesia. This become good moment to us. We have time to participate in the board context, so we can sharing with others expertise to get solutions about the climate change problems. Actually, from Surabaya, me, and then from Universitas Indonesia, Prof. Ari Widodo. And then this is a background of ATC series program. Actually, climate change education in teacher education is limited to the development of teaching materials and classes. This is become used issues not only in our country, in Indonesia, but also in the world. Almost universities, almost school have similar challenge, and then they not yet think about what can they do to get solutions about this context. And then the development of systematic education programs has made little progress in response to global calls for climate change education. This is true and similar in our country. Actually, if try to check in science curriculum in Indonesia, start from elementary until high school, yeah, about the topics of climate is less than actually about the percentage is very small, and then we try to comparing with other materials. The climate change is smaller than others. Sometimes many teachers still think climate change is additional context, not important context. But if we try to check from the impacts of climate change, more than terrible compared to the other one. Now, this become good consideration to us how to arrange good model to teach about the climate change. This is become effort to our expertise from the Asia Pacific researchers, especially about climate change. We try to develop a framework of teacher education programs for climate change education that can be adapted and applied by many teacher education institutions. And then for the collaboration and excellency on ESG is absolutely required. Actually, not only we can make a model of framework of education, but we try to make a simple model so we can apply, we can adapt it for many backgrounds. Actually, we try to comparing between Indonesia and another country. We have different situation. Sometimes we try to comparing behavior, people behavior. Actually, yeah, I think we know that what kind of our people behavior, sometimes not discipline and so on, especially how to think about the waste in our environment. Sometimes, yeah, we just only see, not have actions. What can I do to optimizing to keep our environment and so on. And we try to make connection with ESG. Just a little time, I try to introduce about ESG. ESG is Education for Sustainable Development. Actually, it is a mainly program for the UNESCO that they have 3 pillars. Yeah, actually about environment, about economy, also about social. This become good topics, a good orientation, how to improve our teaching and learning process in the science education. Actually, now we always think about the science is become answer all problems. But if we try to check about the condition now, sometimes we must reconstruction again about our science concept. Actually, we try to make connections with environment, with economic, and with social. We have a good responsibility through science. We can improve our economic society. We can make activity of our society to in science. Like, for example, if we invite them to participate in our projects, this one is good. So then they have good experience how to get solutions about our problems in the environment. This is the concept. And then ATC have one benefit. The numbers of young researchers who will be key figures in the next generations are growing in its center of excellency, allowing research teams to apply a central role in program development in this area. This is a good orientation through ATC or in ATC project. We give good opportunities to many researchers, so they have nice participations in the climate change education to create many solutions, and then we can share country report for each years, according to invitation from Fuji Shinsei. And then this become new models in our collaboration research, and I think very nice and very fruitful to grow it, to build collaboration concepts, especially about climate change education in Indonesia. And then this is Asia Pacific Identity Competency Framework. Actually, we have one orientation. We must able to practice here and not towards shaping sustainable features. This become good point to us. We not only prepare for now, but for next time. And then From the Asia-Pacific competency framework, we can become 3 domains. Start from facilitated learning. Hopefully, the students able to create and provide learning and opportunities for us to develop their sustainability capacity. This become good orientation. We give a good facility to our students, so they can create and provide learning opportunities. And then not only no, but for sustainability capacity. And then about next domain, continue learning kids. Hopefully, we can able to reflect, innovate, and transform knowledge continuously as provision in ECG practices. This is important too. Also, similar way the domain 1, actually innovation and transfer knowledge not only stop now, but we can continue to other as a professional in ECG practices. And then the last domain, connect and collaborate and engage. Hopefully, students able to promote collaborations and partnership to support the ESG policies and practices within and outside immediate communities, including local and national authorities. We try to make opportunities so our students not only know in our frame in our room, but we try to connect with broad, yeah. So they will get good, nice experience to discuss, to communicate with other population, with other communities. I mean, this is a guideline to us how to imply climate change education in our learning. Actually, we have orientation, we have a guideline to develop about cognitive learning objective, and then socio-emotional learning objective, and then behavior learning objective. These similar ways, our purpose in our learning actually not only think about knowledge, but we also think about skill and affective. This is become a similar orientation. And then if you try to check from my slide, actually we will get good learning objectives and very suitable with our project. For the first one, the learner understands and greenhouse effect as natural phenomenon caused by an insulating layer of greenhouse gases. This not only think about the topic of greenhouse effect, but they provide some activity to train our students so they have good skill to understanding about the topic. And then another items you can read from my slide. This one is cognitive learning objective. Then the other one about the social emotional learning objectives. Actually, yeah, I try to pick one examples. The learners is able to explain ecosystem dynamics, the environmental, social, economic become important point in science education, and ethical impact of climate change. Ethical impact. This one's good sign for us because through this one we have many clue, many opportunities to make innovation in our science teaching. And then for behavior learning objectives, where for one example, the learner is able to evaluate whether the benefits and job activities are climate friendly and whether to revise them. This one become behavior learning objectives. Yeah, actually we can take to other points. Okay, then we can choose one from all to imply in our subject matter. Also, we can make learning tools or learning instruments according to all purpose according to this slide. And then this suggested topic for ICoMaSEdu about climate action. Actually, we can choose one from all. Start one, greenhouse gases and the emission, energy, agriculture, industrial greenhouse gas emission. And then sea level rise and consequences for countries, migration and flight related to climate change and so on. Yeah, actually we can modify these topics. We can insert our competencies, like me from physics. I try to use my physics concept to get solutions from topics. For example, about energy. Yeah, actually, I try to modify many tools to get energy or save energy and fruitfulness in our life. This become good innovations in our teaching. And then how to imply the artistry program in Indonesia. This wonderful experience with me and Prof. Ari, also many friends from UPI Bandung. I try to design of the program. Actually, this is created from Prof. Ari, Bu Eli, also Burini from UPI with me also. And then we have three kind of variable. First one is literacy, and the second one is awareness, and the last one is action. And then after that, this become baseline survey, and then we try to I'm sorry. We create a climate change education according to many version, and then we try to check again about the literacy, awareness, and action. This design our program from Indonesian teams, and then this is program activities from Indonesia. Actually, we have 4 subjects. Start from teacher, and then student, school, and then social. I'm sorry. Public, yeah? Okay. Teacher, all students can development of teaching strategies, especially focus on teacher education and teacher professor development. This become clue for many students how to make innovation about climate change education. So you can create about the teacher education. Yeah, we often call models and then teacher professor development. These become good opportunities to create teaching and learning innovation. And then for students, we can assess about the literacy, awareness, and action through teaching strategies. This is more simple than before. Actually, for our students, for the undergraduate level, we can assess, we can measure about the literacy, awareness, and action with imply simple strategies. Through, yeah, you can use project-based learning, also problem-based learning, or other strategies in your teaching. And then about the school, we promote many schools to apply climate change awareness and action, promoting climate change awareness and action. And the public, we invite them to join in our community programs, and we create a new website to access all the information about climate change. So many people can easy to get information about the climate change. And then, I'm sorry. Okay, I try to explain bit by bit, start from program 1, preparing teachers to teach about climate change. Okay, actually, we have 3 main ideas how to promote teachers' competency to teach climate change. Actually, climate change is presented on one of topics in science lesson. So these become good point to us because until now, climate change become small parts from science curriculum. And then the climate change is taught and assessed as science knowledge. Yeah, we give a high portion to climate change material, not only just remind according to situation, but but we must give a high priority to teach about these topics. And then the last one, climate change lost its spirit as an action-oriented topic. Yeah, sometimes we always give big influence from our spirits about to translate about the climate change phenomenon in our surrounding. And then the important point, competencies for teaching climate change need to be integrated into teachers' competencies to teach science. This become good option to make a good research about the climate change in our topics, in our fields. Okay, actually, we can make connection with other topics. Climate change become main topics, and you can modify to integrate with biology, also chemistry, also physics, and so on. And then, for example, about the integrated teacher competency standards, actually, we modify about the science teacher competency standard with EAC teacher competency standard. Actually, we will use standard for science teacher competencies to teach ESD. This become good point, become our results in our research together with Prof. Ari, also many person from UPI Bandung and from Japan. Actually, finally, we have a start of science teacher competence to teach ESD. So make difference with before. Sometimes we only use science teacher competency standards, but not influence, not integrate with EAC teacher competency. This become dissertation from Bu Elia from Bandung, and I'm very appreciate with this results. And then standard of science teacher competencies to teach EAC. Actually, we have 5 standards. We have 5 standards, start from pedagogical content knowledge. PGK is important. Don't forget with PGK. This become my idea in our department. And then the second one is inquiry. I'm sorry. And then professional practice, evaluation, assessment, and professional development. And then the last one is attitude. Attitude is main part. Not only we have high competencies about to teach ESD, but we less attitude. We must proportion between competencies also attitude. This become our responsibility to encourage our students so they have good knowledge, also good attitude. Instrument consists of number of subcompetencies and instrument to assess the competencies being developed and validated. Yeah, the instrument now succeed to produce, and then maybe for next time we can try to imply in our situation, in our environment. And then the importance of the new teacher competency standard, actually science teacher competencies to teach EIC is very important, not only for pre-service teacher, but in service teacher also. This is become good point in our teach about all topics actually connected with climate change. We can try to introduce about the scientific competence to teach EHD to our students. This is very, very, very fruitful to our students. And then this publication from Bu Elia, Prof. Ari, Bu Ida, also Prof. Fuji or Fujishin about the development and validation of an instrument for assessing science teaching competency to teach ESG, and all participants can access this article. And it's very nice to support your research, especially about the ESG, also about climate change. And then the second program, actually, we have time to exploring teaching strategies to raise students' awareness and willingness to act on climate change. Yeah, this become good stage in our progress in research. So I try to show you what kind of research. Actually, this is mapping our teaching strategies to assess about literacy, awareness, also action. Actually, this one becomes strategy to promote student literacy and readiness to act. Yeah, you can see from the slide what kind of teaching strategy, not only conventional model, but we apply computer modeling and experiment, feature workshop, making documentary videos and changes of course line, immersive virtual learning, experiential learning, and STEM. STEMs become a good point to teach about the climate change now, because they have a good application. Yeah, especially if we try to integrate with project-based learning, STEM is nice. And then The third program, promoting climate change awareness and action to schools. This is my project with my team. We often call for resilience for sustainability. The theme, ayo tumbuhkan kesadaran aksi nyata generasi muda dalam penanggulangan perubahan iklim. This one becomes school competition on climate change action. And then we get a nice appreciation for many schools in Indonesia. And then if you check from these numbers, actually we have 37 junior high schools participants and then 16 senior high schools participants. And then participating individuals until 657 students and 84 teachers. These regional districts, we have 37 districts, start from Kabupaten Bandung Barat until Tasikmalaya. We have many towns, many cities like Surabaya also, Medan, Mojokerto, Samarinda, Sukabumi, and so on. Then 12 provinces, 11 provinces. Okay, Banten, DKI with different percentage. Okay, and then this distribution, here we have coverage among many provinces, yeah, until most province participates in our programs. And then financial support from Wardana, media partner, Green Generation Foundation. And then this is where actually UNISA have times to announce for the winners. Actually, because all winners from Surabaya, start from juara 1, juara 2, harapan 2, juara 3, and yeah, thank you to Pak WR 4 also, Ibu WR 3. Okay, thank you very much. And then this is I try to check about the question result from student experiences of the resilience. Actually, this is a result from the, maybe you not know what our question about this one, but after the slide you can see where is high position and where is the lower position. Actually, this is orientations of students' response according to our programs. Actually, we have 10 points, and then item points. Actually, these all points become good points to all students. They understand more about the things that cause global warming and climate change. They understand better that global warming and climate change affect life on Earth, and so on. Actually, this become important data for us. So through these programs, we can we can promote all students so he or she have good understanding, good behavior about the climate change. Actually, from these programs we can make simple conclusion to teach about climate change, not only transfer knowledge to others, but give change to participants in action. And then example activities. This is one project from SMP 16 Surabaya. We often call Green School Program. They are optimizing patient food to reduce climate change impact on the school through pollination program and make high nutrition drink from patient food to support each in this program on the school. Thank you very much to Bu Deborah, because she has good orientation. She has good support to our programs in SMP 16 Surabaya. And then this is SMP 16 Surabaya, very nice and very green and very healthy. And then this is the process patient food to become high nutrition drinking. Maybe give exercise to students how to make high nutrition drinking from patient food. Patient food we often call markisa in bahasa. Yeah, so This is become representations how to integration EAC in our concept in teaching. And then this is one program in SMP Negeri 21 Surabaya about the hydroponic and evolve to reduce climate change impact through through science learning and optimizing organic waste to become fertilizer. Through this one, we can check about the hydroponic programs. So very nice. And SMP and 21 Surabaya become abbreviated schools. And then they give participants to all, not only students, also teachers have time to contribute in the programs, in this program, producing fertilizer liquid form-based processing. And then this is a composter program, very nice. And then this one is climate education program, and this is umbrella. Actually, I try to show you this not only stop in here, but I try to share with my students who will get opportunities to research in about climate change education. Actually, we have three levels that form undergraduate research. There are Nuris Soba. The title research is implementation of the PBL model with the utilization of weather station in increasing climate change, awareness of hydrometeorological disaster mitigation in high schools, and Aimatul Afifa, the implementation of problem learning or PBL model on climate change, materials to improve student scientific literacy. And then about the graduate research, Susanti Ida Pratiwi, development of science modules with STEAM project integrated with EAC to increase students' creativity and sustainability awareness in curriculum Merdeka, and Bu Huswina, development and inquiry-based module on global warming materials to promote student scientific reasoning and sustainability awareness. And the last one, Ibu Nurita, developing teaching models of climate change education based on STEM to improve scientific literacy to support physics, sustainability, and sustainable education. This is a simple form doctorate students. And then the last program, promoting climate change awareness to public. Actually, we have a nice website. We often call Gerakan ESD Indonesia or Indonesia ESD Movement. Actually, this is a new website about climate change education. The members from lecturers, teachers, students, membership is open to everyone. Who all participants in the seminar, if you have time to join in our programs, I'm okay. We also invite other organizations and companies to join the movement and publish a website and social media. And then this is my website face. Mari bergandeng tangan memajukan pendidikan untuk membangun berkelanjutan. Okay, this is next. Thank you to our program. Is supported by tens of dedicated members. About pictures of some members are available in our website. Yeah, actually, you have time. If you have time to visit my website, yeah, please, yeah. And then this is teams. Prof. Ari from UPI, I from UNESA, Purini Solihat from UPI also, Pu Elia also from UPI. And then special thanks to Okayama University, especially for my sensei, Hiroki Fuji PhD, UNESCO Chair in Research and Education for Sustainable Development, Director Okayama University Promotion Center. And then the last one, thank you. Okay, thank you, Pak Heri Wijayanto.
Okay, thank you so much, Dr. Eko, for the nice presentation. So I know that research on education is challenging because it's related to the behavior changing of human, especially for students. So it's not important to, it's not easy to change the behavior of human. So I would like to invite all participants. If you have any question, you may raise hand or you write it in the chat box. Please. Dr. Eko, I have a question for you.
Okay, please, Pak Ari.
So I was wondering about the about our country, because as we know that Indonesia is a huge country, right? So and we still have a remote area, especially in the eastern part of Indonesia. If we take a look at the education, equation in Indonesia, it's also still big issues, right? So we have still many remote area. Do you think that your study can be applied to this area?
Yeah, of course, but Harry, actually this program is very potential to apply not only for small area, but we can apply to big area like in our country. Because this become adaptive programs, we can modify according to our context. Like in, for example, in Jawa Timur, in East Java. Actually, East Java have bad situations about climate impact in coastal. Actually, we can optimizing the example about the coastal area, how to face climate change impact in the area, in this area. Yeah, not only through by examples, but we can integrate with our expertise like in physics. Yeah, actually we can make or we can create simple models to support climate change education program. Like we can make simple boats through solar panel or solar cell. This become good option. So then all feature not use fuel from the I'm sorry, coal, but we can use solar cell. The other side, we can think again. Maybe many participants have idea to make a simple boat use wind energy. This become good idea. Actually, to get solutions about the climate change, not with big action, but we can through small action in our daily life. Start from keep ourselves with many ways, yeah, and then until we can make a good solution through our focus, our jobs. This become good strategies to introduce about climate change education to our students, because the climate change have many variables, many aspects, not only about context, but also about contents, about attitude, about behavior, about environment, about economic, about social, and so on. We have many parts to keep one aspect to participate inside. I think this one, Pak Heri, I'm sorry. Maybe my pronunciation is not clear. I'm sorry because I'm not English person. I'm
That's
Indonesia.
very clear. That's very clear. But
Okay, thank you.
yeah, thank you so much. But I'm also quite interesting to to know how to maintain your concept, your study, so that it can be sustainable for the future. We know that, as I mentioned previously, that what's that? Change the behavior of human is also difficult. So how to maintain this concept?
Yeah, actually we can through modeling, Pak Heri. Actually, for me, become teachers to our students.
Okay.
I must show to them about good models, like how to keep my waste in our surrounding. Sometimes after I use tissue, I not put for other place, but I will keep my tissues in our bag. So then I will bring to waste place. This become good models to keep our environmental condition. Start from simple action. Action is more important than others, but sometimes we avoid this context. We only have orientation about how to transfer our knowledge to students. But this one is not fruitful to our students if we avoid about the attitude, about the behavior. What can give appreciation about the water. Water is very important in our life. But sometimes if we have one water, we always not maximum to drink this one. Sometimes we up this water to other place, and this one is not good to constructing mind habit about the climate change education to our students. Yeah, we can start bit by bit, but not from a big project, big program, but we can
Okay,
through small topics.
thank
Okay.
you. I got the point. But
Okay.
I'm also curious about your opinion about how to reach to the government levels, like to be applied in the curriculum or something like that.
Yeah, actually, we have times to create curriculum models, but actually, me and Prof. Nadi have a subject matter about curriculum development. And I try to promote my students to create a new model of curriculum, science curriculum, especially connected with climate change education, also about ESD and SDGs. This has become a good monumental ideas, and then I try to share for every time. Like now, I try to introduce to you and all participants about the new models, how to teach about the climate change through in addition with our topic. We can talk about climate change through physics. We can teach about climate change through biology, and then we can teach about climate change through chemistry. This become good model. Also, we can make integration all become new models again. So we can create a new model for uh, climate change education to many conditions. This become good for my government. Actually, after we have good models and we can become a fixed document, and then we have time to communications with them in pusat, in centers government. Yeah, actually, we have opportunity to give idea to them. This one become good ways to support climate change education, climate change education in Indonesia. I think this one, but
Yeah. So your group are trying to communicate to
yeah,
the
yeah,
government.
yeah.
Right? Yeah.
Yes, right. That's right.
Okay. Maybe one more question.
Okay.
Oh, I just want to know how the response or feedback from the student after applying your concept. Is
Yeah.
they
Okay.
happy or maybe feeling this is complicated stuff or something like that?
Yeah, actually, you can check from my research umbrella, Pak Heri.
Okay.
We have many students participation in our research to modifications between climate change education context with the EAC. This become good information to us because this is good topics, full innovations, full novelty. Because if we try to check for many publications about the climate change, sometimes about the climate change education is less than others. Uh, they have small amounts comparing with climate change only. Yeah, actually we can differentiate between climate change education and climate change. This have we have responsibilities to teach about climate change, not only research about the climate change. This one, Pak Heri.
Okay. Thank you so much for
Okay, you're welcome.
answering my question. I think this is the last question, the end of our session for the second speaker.
Moderator,
Okay.
I think you have to check the chat box. The
Okay.
question from the participants.
I'm sorry. Okay. One question from Pak Hendra.
Okay.
So he is a doctoral program in mathematics education UNESA, Universitas Negeri Surabaya. One question for Dr. Eko. How about the role mathematics in science education? Please give me some example about it and how to collaborate it.
Okay, thank you, Pak Heri. I have one terms to promote mathematics context in science education. Mathematics I often call king of science, and physics become queen of science. Actually, become between mathematics and physics become one part in one part. They can working together, not only for physics, but mathematics become a good vessel to get solutions for many problems according to climate change. For example, sometimes we need mathematic measurement to get information about carbon dioxide concentration, for simple example. But another side, maybe we need to make a good programs, good simulations, how to teach about the climate change problems to our students. Sometimes we only teach by conventional models, just give information about definition about weather, about climate, and so on. But we know that our students now not only need about information, so then they can get more information from many resources. But now we must provide good models to teach about the climate change. This is become mathematics area very important to all mathematic expertise. You can combination not only think about numbers, but how to get applications in mathematics to teach about climate change. This one become good models, and then I promise this is a good innovation to integrations between mathematics and science education. I think this one, Pak Harry. Yeah, this is my answer.
Okay, thank you so much.
Okay, you're
Uh,
welcome.
Okay. Any feedback? Yeah, okay. Thank you from Pak Hendra. Okay, so the next question from Pak Aris is raising his hand,
Okay,
please.
please.
Thank you very much for this. Good afternoon. Good morning, Pak Eko.
Good morning, Pak Aris.
In our curriculum, we are very concerned about.
I'm sorry, Pak Aris, your voice is not clear because we have
Okay.
another resource voice in our.
Okay.
I'm sorry. Can you make right in the chat box? Maybe Pak Harry help you to read your message.
Okay.
Is it clear right now?
It's
Yeah,
okay,
yeah.
actually.
Oh,
it's
okay. Thank you very much. In our curriculum, we are very concerned about mitigation, as we know that students might think that the places that they are living is very safe. Yeah. How to embrace your practice that you already explained related to mitigation? How to use the and the teacher try to develop the interaction for the student that they think that the places they're living is safe. How to the instruction at first, and what sources that the teacher need to make the instruction.
Yeah. Okay. Thank you, Pak.
Thank you
Aris.
very much.
Okay. Pak Aris, can I respond all question from
Yes,
Pak Aris?
please.
Okay. Thank you. Yeah, Pak Aris, thank you for your questions. This good point for us how to optimizing mitigations in our teaching practice. Yeah, mitigation is very important, but especially we know that the main topic of mitigation is how to what I means how to keep your students safe from all disasters in the surrounding. So one point to exercise about the mitigations, we not only teach about the mitigation meaning, but give opportunity to predict, to observe, to assess all situation from the surrounding. Sometimes give opportunities to your students and bring out the room, so then give time to observations or phenomenon in the surrounding, and then they can predict what happened for next time according to observation results. Start from like situation land inside land in land area. Yeah, Paris maybe have experience of if you go to Semeru area, and you observe all situation in there. Sometimes we terrible to see about the land. The land is very terrible. Yeah, they only one force maybe will be down to other place. This is very terrible to our students, and then this has become main issues, and then we can give a solution to them. We can give a guide to them. What can they do? Uh, Mainly these topics not only teach about the mitigation through information, give opportunity to our students with practice, with a simple practice like observation, and then prediction, and then measurement according to all conditions in our environment. This one, Pak Aris. I'm sorry if my pronunciation is not clear. Yeah?
Okay.
I'm sorry.
It's
I'm
very
sorry.
clear. It's very clear, sir.
Okay,
Thank you
okay.
very much for
Okay,
your
you're
answer.
welcome. Okay, thank you.
Okay.
Thank you, Pak Aris, for the question, and thank you, Dr. Eko, for your
Okay, you're
response.
welcome.
And
And-
yeah, I think this is the last question, and
Okay.
the time is up.
Okay.
So I would like to say thank you so much for
You're welcome.
Dr. Eko for attending this conference, for answering all the questions from the participant. That was a really nice presentation and discussion actually. And
Okay,
and your theme is your presentation is actually fit well with our theme, which is about the collaboration of science and education to solve
according to your topics, seminars, right?
yeah
Your topic seminars, right?
yeah right. That's very fit, and in this case related to the SDG climate change.
Okay.
So let me highlight your presentation. So your research highlighted the important things of education to increase the motivation to students to become pioneers, and hopefully this pioneer can spread the motivation to other schools in Indonesia about the knowledge of climate change. And this is a key that a strong connection should be maintained to achieve the goal. And Dr. Eko also highlighted his research actually will overcome two points from SDGs. The first one, I took a note here. The first one is number 4. It's about quality education. And the second one is about climate change, number 13. The problem is in Indonesia especially, actually SDGs education already applied, but they only know the concept. The problem is how to imply or apply to the concept to the daily life. So that's I got from your presentation. Then the second one is also important. I'm quite interested about this. So about the program activities. So this how to say the SDGs education, the climate change education, first coming from the teacher, then transfer to the students. Yeah, and this is the school system, right?
Yes.
School system. Then hopefully the school can be what's that, the agent of change or agent of promoting, maybe the promoting the climate change awareness and action to the public. This is very interesting because usually this role is for university. University usually take this role via maybe publish paper or community service, but this is from the school. That's also very important. And so hopefully your research can improve the awareness of climate change in the world, especially in Indonesia.
Okay.
So okay,
I'm sorry, one information, Pak Hari, just information to all. Actually, for the November, UNESA will become host to international meeting with 9 countries members from ATC. Yeah, in November 15, inshallah. Hopefully become good moment to our university. So then we have opportunity to to pursue international level for UNESA.
Okay.
That's
Oh,
information.
it's very nice information. So is that open for any academics?
Yeah, hopefully they will give collaboration teaching with all students from Okayama, also from Bandung, also from Surabaya. Maybe for the September we will share about the rundown to all participants. Hopefully.
Okay, thank you so much, Dr. Eko.
Okay.
So once again, Dr. Eko, thank you for joining us
You're
here.
welcome.
It's a great honor to have you as a keynote speaker.
Okay,
And before we take some break, on behalf of committee, I would like to award you, Dr. Eko, the certificate of appreciation, keynote speaker. Here it
Okay,
is.
thank you, Pak Heri.
And Dr. Eko, I have your time to take a picture.
Okay.
So for MC, Anesia, could you please help me to take the picture?
Thank you. Okay, thank you, Dr. Heri Wijayanto. Please hold a moment so that the committee will take the screenshot. Please give up your space, pose, and smile. Now let's take a picture in 3, 2, 1. This documentation session is already over. Thank you so much. I will return the session to Dr. Heri Wijayanto. Time is yours.
Okay, thank you so much. Once again, thank you for your time, Dr. Eko.
Thank you.
See you next time.
See you.
And
Nice to see you again.
for all the participants, now we are in the last session of the first session.
Can I leave now, Pak Heri?
Yeah, please.
Okay,
That's
thank you very
okay.
much.
Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, and also thank you for the participant for your question. We have already discussed, and I will give back to Anesia, Master of Ceremony, to handle this event. Thank you.
Okay, thank you. Thank you, Professor Sataruna Kasima and Dr. Eko Haryono for giving such informative and comprehensive presentation. And also, thank you for Dr. Heri Wijayanto for hosting the first keynote speech session so well. Let's give them another round of applause for the excellent presentation. For the participant, don't forget to fill the attendance sheet that you can click in the link chat below in the chat box. This attendance is used as a requirement for obtaining a certificate, so please fill it correctly. Ladies and gentlemen, we are now in a break session that lasts for 1.5 hours, followed by parallel session. For your information, the next session is the parallel session day 1. That will be start at 12:30 Jakarta time. Parallel session will be start in some rooms. For presenter, please check your schedule to know about the session location. Don't forget to rename your account to the present format so the committee will be easy to identify you and help you to join your breakout room. We will also like to remind you to use this time wisely and don't forget to come back because there is still other agenda. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Enjoy your break session.
Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the three pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya
Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ecopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science UNESA constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science UNESA must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science UNESA currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science UNESA, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science UNESA community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science UNESA implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science UNESA is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science UNESA prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates UNESA's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science UNESA also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science UNESA are open access. Furthermore, Faculty of Mathematics and Natural Science UNESA is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science UNESA's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science UNESA continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA UNESA memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA UNESA telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA UNESA memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills.
Halo, Pak Fasi. Halo, Pak Fasi. Halo Bu Mitarlis, Berta.
Waalaikumsalam, nggih Bu Dita.
Nggih, langsung
Nggih.
saya assign ke room 2 ya Bu.
Oh,
Bu
nggih.
Berta.
Untuk besok tetap room 2, tetapi
Iya Ibu.
nggih.
Nih.
Baik, saya langsung
Nih.
join nggih Bu.
Iya Ibu.
Makasih.
Ya, sama-sama. Selamat siang, Bu Dwi. Assalamualaikum, Bu Dwi. Recording in progress.
Attention please, the second session is about to begin. Thank you for your attention. Ladies and gentlemen, without further ado, now we will begin the second session of keynote speech, which will be delivered by Professor Peter C. van Welzen from Stanford University and will be hosted by Dr. Fasi Bintang Ilhami. Dr. Fasi Bintang Ilhami is from Natural Science Department of Universitas Negeri Surabaya, and his area of expertise is nanotechnology. Ladies and gentlemen, please welcome Dr. Fasi Bintang Ilhami.
Okay, thank you very much. Good afternoon, ladies and gentlemen. Welcome back to the second section of International Conference of Mathematics, Science, and Education's 2023. My name is Fasi Bintang Ilhami, and I'm going to be the moderator in these sections. We have two speakers who are already with us right now. We have Professor Peter Cornelis van Welzen from Leiden University and Dr. Zoltan Kovac from University of Debrecen, Hungary. And I would like to greet to Professor Peter Cornelis van Welzen first. Hello, Professor.
Hello, can you hear me?
Yeah, I heard you.
Okay.
Good morning, Professor. I think the time is still 8 o'clock, right?
Well, I'm in Thailand, so at the same time as you.
Oh, okay.
Good afternoon.
Okay.
So good day.
Okay, all right. So may I call you with Professor Peter? Is it?
Yes, please. Yes.
Okay, thank you so much. All right. For your information, our audience are faculties, researchers, and students also. So quite various background over here. And before we begin, I have a few housekeeping notes. The speaker will be talk around 40 minutes, and we will have a discussion time about 15 minutes. If you have a question, you can ask your question during the session by raising your hands, or you can type your question in the chat box, and I'm going to read them for you. Well, I would like to read briefly the profile from Professor Peter. Okay, the full name is Professor Peter Cornelis van Welzen. He is a professor in tropical plant biogeography in Leiden University, Netherlands. His research focus has two directions, which is content with the species of family of Corbiaceae in Malaysia and the distribution of the plant in SA Asia. And his educations, he already finished the PhD degree at 1990, which is quite long, I think. And he got the several honor and awards, but the very recently award is Top 10 New Species Award from the discovery of Dracaena kawasaki at 2014. And he has in editorial journal, and he has some 150 publication in the top range journal. So I think we will have some interesting speaker today. And that's all the briefly the profile from Professor Peter.
Okay, thank you.
Okay, Professor Peter will be deliver presentation on the topic plant taxonomy as corporation, innovation, and productivity. Moving along to our session, please welcome to Professor Peter.
You have 40 minutes to present your work. Please.
Well, thank you very much. So let me go to the first screen. Well, thank you very much for inviting me for this symposium. I hope you can see the presentation.
Yes, I can see clearly, Professor.
Okay, thank you. So I will talk about plant taxonomy, biology, and I will not go into much detail. So I hope it will be for a more general public. So I will show with plant taxonomy that we need far more cooperation and innovation to get a higher productivity. I will mainly talk about Flora Malaysiana, so the flora of the Malaysian region. And this was more or less started in the 1950s by Van Steenis. So he wanted to describe the flora of Indonesia, but he did not want artificial borders. So he looked for natural borders. And that's why this area is a bit bigger than just Indonesia. So Flora Malaysiana. So let me briefly introduce. I work for the Alice Biodiversity Center in Leiden, which is about halfway the Netherlands along the coast. Well, this is partly a museum, and we are in the top 10 of the Netherlands. And as you can see, the top piece is in fact an almost complete skeleton of a T-Rex. Next to that, we have an enormous collection, and we are at the top 10. There are also researchers in this museum, of which I am one, and then there's a big ICT department. So let's start with the with the talk. So this is in fact, one of our former storages for plants. So as you can see, we had about 5 million specimens, so they're stored in huge space. So you must imagine that these rows are about 2.5 meters high with boxes, and in the boxes you have the plants in folders, and in folders again. In fact, this herbarium method of dried plants stuck to pieces of paper started in around 1550 in Italy. And we have one example in our herbarium, a very old herbarium, the Antibi herbarium, which is around 1580. And you can see that in those days, they were not just glued to separate pieces of paper, but just put in a book. And in fact, they were not meant for research yet, but just to please the eye. So these were in fact presents to rich ladies. So later on, especially Linnaeus introduced the idea to have the plants mounted on separate sheets. So you get examples like in the left bottom corner. And in those days, it was quite nice. They put these little vases because they did not like the cut ends of the branches. But as you can see, there's little information on these sheets. So if you go to the modern sheets, which you see here, you see there's a big label with a lot of information. And that's mainly the information which is in fact lost when you make a plant specimen. So about colors, height, where collected, etc. So the question is, how can something so old, ugly, and often boring lead to cooperation, innovation, and productivity? And we have quite a lot of these specimens, so about 390 million in more than 3,000 herbariums worldwide. Well, why do we make an herbarium? Well, the nice thing about this, you can study them throughout the year and officially for eternity. So if you only use fresh material, you can only look at the specimens in your neighborhood, and then only during part of the year they will flower and fruit. And now I can just study specimens from Indonesia, and they will flower and fruit the whole year through. Well, I have here some examples of plants from the Netherlands. So my question to you is, how many species do we have here? Well, it's a nasty question, and I think you will probably look at the color of the flowers. Well, those are not the characters. In fact, you have to look at the width of the leaf. So in one group, they are below the middle, in the other group above the middle. Then these lobes at the side, they can be quite big or much smaller. And then the venation, so the nerves can be impressed or they can be flat. And then in fact, the foot of the leaf blade is also a bit different. So basically we have two species here, Veronica camidris and Veronica officinalis. So this is basically the work of taxonomy. Find characters which are constantly different between groups of plants, and then you call these groups species. In fact, you have to check this with all the specimens, also if specimens are later collected, so you can still test your differences. So we just make the piles and check them, and then we can see, okay, this is all right, we have two species. But now the nasty part, this morphological work takes a lot of time. So it's very tedious work, very slow, because what works in one group as a character doesn't work in another group. So every time you have to start anew with looking what can be characters. So this means that taxonomy is a very slow process. Taxonomy often, especially for Malaysia, is revision work. There are many names, and we take all these names into account, and we just see if their circumscriptions as species are correct or not. So why do we also take the old names into account and not only new species? Well, as you know, from Europe, we were quite nasty, and we conquered large parts of Southeast Asia. So you had the French in Southeast Asia, you had the English in Malaysia, the Dutch in Indonesia, the Portuguese in Timor-Leste, the Spaniards and later the Americans in the Philippines, and then the Germans in Papua New Guinea. And all of these started to describe the flora as they saw it. So the same species got a name in New Guinea, it got a name in Timor-Leste, in Indonesia, etc. So many names are synonyms. So we have to separate the synonyms of the accepted names, which are usually the oldest names. And what also often happens is that somebody just studies one little island, describes a new species, which later appears to be part of a very widespread and very variable species. So again, a synonym. Well, for this Flora malaysiana, we estimate that there are about 45,000 species. So that's quite a lot. If you compare it, for instance, with the Netherlands, where we have 1,500, so about a third of the number of species of Indonesia. And even we have a lot of problems describing these 1,500. Well, this Flora malaysiana project is now busy for 75 years, and about a third is really revised. So that's very, very low, very, very slow. But at the moment, yeah, many species are threatened. So we have too many people on this globe. So we use a lot of land for housing, for factories, for food. And we produce a lot of waste, so there's a lot of climate change. So all these things threaten the species which we have. And quite often we don't even know which species they are threatening. So we have to increase the speed of Flora malaysiana. So one of the things by which you can speed up is innovation. So people then often say, okay, why not use molecular data? Because yeah, they are now used everywhere. And in fact, we do it already for several decades. But herbarium specimens are a bit difficult. If you dry them too slow, the DNA will fragment and you don't get very good sequences. And you should also realize that there are many other, in fact, plants and animals living on these leaves. So like bacteria, fungi, and in tropical countries also lichens, mosses, and often small ferns. So there's a lot of DNA which you don't want. So you have to separate from that. So quite often we tend to the DNA of chloroplast, because then we already lose the bacteria and the fungi. But again, with chloroplast, there are some problems. It appears that within areas, species which are more or less related can exchange their chloroplast DNA. So that gives a false information if you want to look for the evolution of a group. So in former times, people would not dry species when they were collecting in tropical areas. It was too humid, so if you dry them, you have to keep on drying them because otherwise they get wet again. So what they did quite often was they put them in, between newspaper, put them in a plastic bag, poured some alcohol over it, sealed the bag, and then sent it off. And then much later, even months later, it was properly dried. However, unfortunately, the alcohol use was not enough, so it did not kill the cells too fast. So often those specimens, and they look very brown and black, so that's why you can recognize them. They have very fragmented DNA, so they're not very suitable for molecular information. So nowadays, when we collect, we also have a small bag of silica gel, and we make a specimen, and we collect also a small leaf in the silica gel, and that we can use later for DNA research. But old specimens are a problem. But luckily, we have a new method with next gene sequencing. There's a new method called HIPSEQ, so hybridized sequencing. I'm not going to explain it, but the nice thing is that with this method, you cut up the DNA in very small fragments. So basically, it is very suitable for herbarium specimens, which are already in small pieces. So these pieces are treated in various ways, selected, amplified with PCR, and then sequenced. So in the end, you have a lot of short sequences, which you then have to calculate together. So that's a lot of work. And at the moment, Eva Christiane Watti from your university, she's a PhD in Leiden. She's busy trying to use this method to see if with this method we can speed up flora work. So at the moment, she's busy with her first try of HIPSEQ. So I think about halfway. So what do we want? Well, what we want is that we make sequences of all the specimens which we have. And then we have a program with which we can make a kind of evolution of a group. And then we hope that the specimens belonging to one species will come together. And that is shown here. So this is a gene that's called Phoria. And you can see that if, for instance, this Phoria avilla, there were 12 specimens and they all group together here at the bottom. So they come from one branch. So this is quite nice. It indicates a species. Here the same with Aurantiaca coming from one branch. So in fact, with all these species, that is more or less the same. It also points at some problems still. So here we have Phoria cerula, and there are two other ones here which look like it, but they are in a different branch. So you might combine them, or you might call them a different species. So this helps very much already to see what species we have. Oh, by the way, this is quite a very funny group because they are parasites on fungi. So they have no chloroplast. In fact, if you want, you can now already look for morphology. So can you also see morphological differences between these groups so that you can recognize them yourself without doing all this molecular work? But you can also use another method which is now used worldwide. And that is species image recognition. So normally we get a view with our eye. Somebody explains you, that is your neighbor. So next time when you see your neighbor, you will recognize him and you will say, hello, neighbor, how are you? So that's the whole idea. But now the pictures are taken indeed with a camera. They go to software which make a kind of memory. So next time this memory is presented in another way, it will recognize it and say, okay, this is this and this plant, for instance. So that will help you to really identify specimens. In fact, in Holland, we already have developed an app. So our institute has done that, which is called Ops Identify, Observation Identifications. So you have your telephone, you point your camera at the plant of which you want to know this, the name. You press the blue button at the bottom, and within seconds you get a name and also a chance. So for instance, with this plant, it will say, this is Dianthus albus, and we have a 99% sure certainty. So that is good enough, you know the name. But the nice thing is, this picture is also stored in a database, and which is again used to let the program learn more and more plants, so that in the future it can also recognize more difficult pictures. Another nice thing is that you use your telephone. So your telephone has GPS. So we also know, directly where the plant was found. So this also gives us a way of monitoring where species are and if they decrease and increase, so if they are threatened or not. So Ops Identify is quite important and you can just have it for free. In fact, there are different programs also worldwide which you can use. But now, yeah, we have dried plants. We have used some of them to make molecular sequences to find our species. And now we like to check if there are more specimens in the herbarium which are the same species. So in fact, you should have pictures of all the plant species or all the plant specimens. And I hope this will work. I will try it. So I hope you can see the movie now.
Still not.
Sorry?
Still not, I think, because I couldn't see the movie. Hello, Peter.
Yes. No, it's not working. It is. Try again. Sorry. Well, this is no. I forgot one key. So now it should work, I hope. Can you see it now?
Yes, we can see clearly, I think.
Okay. So what we did is we digitized.
So could you please make it enlarged?
In the institute. Is it working?
Yeah, it's working, but could you make it more enlarged? Yeah.
Okay. So it went to belts, in which we put automatically all the specimens. So they are taken out of the folders, put on this belt. And this is really tedious work. So these people could only do it for a short period, but it is too dull work. So here you see the different specimens. They are put between, sometimes there's an extra dot added. They are put between these circles with different colors. So to check the color barcode to it, and they're photographed and out if it's correct or not with different tests. And then they are taken off again and put in the same sequence in the boxes again. So this we did for 4 million specimens with 3 different belts. And in the end, with 2 teams per day, so 2 teams of 8 hours per day. So they did about 30,000 specimens per day. So that took 1.5 years. So I stopped with this one. Now I'm afraid I'm back. Yeah. Okay, you now see the presentation again?
Yes.
Okay. So we have these photos of all these specimens. So I show you 4 here. So now what we will do is we will use the specimens from which we had the DNA to let the software for image recognition learn what the species look like. And then it can go through the herbarium photos to see if there are more specimens which belong to these species. So if in the end, we get bigger piles with all the specimens belonging to the species. And it will then also be easier to find morphological differences between them. So in this way, we hope that we can speed up this flora writing in a more technical way. But of course, if you want to speed up, you can also collaborate with more people. Well, in a way, this Flora Malaysiana project is very ambitious because many species involved, a very big area and many countries. At the moment, most small families are done. It's only the very big families which are left, and some are well underway, but it takes a lot of time. And usually, these families are published per family. So we have usually a team, like I do Euphobiaceae, so I have a team of people helping me revising different groups. And I just coordinate and do some of the groups myself. But perhaps this project is too ambitious because one of the problems is also, we have multiple countries and they do not always like each other. So they often do not really cooperate. So one solution there might be that every country does part of a family. So only the plants present in their country. And then the coordinator will put them together into one big revision for the whole region. So for instance, now in Indonesia, you are revising the family Pandanacea. And then we hopefully get also people in Malaysia, Philippines, etc., to do the same. We have one coordinator in Switzerland who can then piece them together into one publication. So hopefully then with training in molecular techniques and image recognition, we can speed up this process and also make it perhaps more interesting because you do many more different things than just look at dried plants. So collaboration is also difficult because less and less people are practicing plant taxonomy. So when I started as a student, there were about 20 people in Leiden working on Flora malaysiana, and now I'm the last left. And I retire in 2 years. So another source which we can use is citizen science. So there are many, many people who often like to help. And with some training, they can easily make observations and do collecting. So for instance, here in Thailand, there are many clubs, nature clubs. So in the weekend, they will go out and enjoy nature. So quite often, if you ask people to do something extra, they will easily do it. Also, especially in the Netherlands, they like to use these apps, so they make it more interesting. Usually you start with simple projects. And the nice thing is that, people become more aware of nature, start to appreciate nature more and more. So they help with nature protection. And they're also willing to take measures to regain control over our climate. So a lot of people now in the Netherlands are what they call busy with the energy transition. So they stop to use fossil carbon, and now they only use electricity produced by wind and sunlight. So I will just give you a few examples of the citizen science project which we have in the Netherlands. So one of them is simply counting. So one day per year, for half an hour, you, for instance, count which bees you have in your garden. So the bees and the bumblebees, hoverflies and wasps. So you just put in the number of the specimens you see, and then you send this per telephone to the coordinator. And in this way, we can just count how many bees are active in the Netherlands. We do the same with birds. And for instance, one day at the beach with seashells. And the nice thing again is you send your data per telephone. So we have GPS data. So we exactly know where the birds and bees are found. So if you do this every year, you can also again see if species become threatened. Another nice project, and this is just to learn people to appreciate nature, is to look at weeds. So weeds which are growing in the streets, which people usually like to get rid of. And the funny thing is, this really is interesting to them. So they're already taking measures to protect them. So they make special tiles in which they put the weeds, or they make special tiles in which the weeds can grow, and it even looks nice. So you get more appreciation for nature, even in cities. So this is also a nice way for children to learn them to appreciate nature. And in fact, most of the natural history museums, they have teaching material about this for children. So you can come to the museum or they can come to your school. Sorry. We have a very important project, which is called Floron. This is floristic research of the Netherlands. So this is done by a network of volunteers, but quite knowledgeable volunteers. So every year they make inventories of the plants in certain areas and give their results to district managers, and these go then to Naturalis. So this is a way of monitoring increase and decrease in the flora. So here you see squares. So these are the old observations before 1919, and the circles are after 1990. So you see that it changed from 50 to 19 of these symbols. So there's a slight increase in this species. But this is not always the case with all species. So this monitoring is becoming increasingly important. So it is important to know which species become threatened. And if they are threatened, we have to find out by what, so we can change things. Also, if new species arrive, will they become invasive or not? So you have to keep track of that. Well, in Indonesia, we have far too many species to learn. So what you can also do is select just a few target species which are representative for a certain habitat. So for instance, the beach, forest, etc. And then your first inventory will be a starting point. So you will later on refer always to this 0 point. And if you start with an inventory, take care that it is good weather, because if it is raining or cold, flowers will remain closed and there will be less insects active, so you don't see enough. It's also nice to visit the same place several times per year, because the first time you come, some of the plants will not be flowering or fruiting, so perhaps you don't recognize them. And if you come at other times, they might flower or fruit, and then it's easier to recognize them and identify them. So this monitoring is helping the Netherlands quite a lot, because we have a lot of problems. You have too much nitrogen, which makes the soil very sour, very acidic. We have too much carbon dioxide, too much bad water, etc. So now on European level, there is legislation that nitrogen should be reduced. But in fact, the government of the Netherlands was not doing very much about this. So a lot of these nature groups, they went to the courts and the judges gave them said that they were correct. So the government should do more to reduce nitrogen. So now they are in a very nasty situation because they cannot build anymore. Because if you build new houses, they will cause extra nitrogen. So you are only allowed to do this if there are other projects which will reduce nitrogen. So at the moment, we need quite a lot of houses. We have a shortage, but we cannot build them because of this legislation. And in fact, it is meant to improve nature. So hopefully in the future, it will start to work. But at the moment, our government is very fixed on solving this nitrogen problem. But in fact, they are all connected. So it is better to go for an integrated approach and also include water quality, carbon dioxide, etc. And especially in Holland, the farmers with their very high production, they take care of about a third or half of the nitrogen and the carbon dioxide, and also with pesticides and insecticides for a very bad water quality. So there we have to change most. So they have to produce less. And there are new techniques already by which they can do it. So in former times, you had big fields with all the same crop in it. And nowadays they found out that if you have small, narrow pieces of land and you have different crops per piece, so per strip, there's another crop, it works much better than in between. You also have strips where you just leave it bare so that nature can just grow their own plant species there, and often also the insects which control the pest insects in your crops. So these people might have a slightly less high production, but they don't need fertilizer and they don't need pesticides. So that saves them a lot of money. So their income is about the same as these people with these very big pieces of land with only one crop. So if you move to this kind of farming, then indeed you already reduce problems like nitrogen and carbon dioxide. But we are still in the process of changing, but we have to do it fast. You cannot go into nature to monitor if you have not enough people. What you can also do is another technique. This is called distribution modeling. So you can try to make a mathematical model to see where a species can grow. So here it is done for Thailand with a species called Dimocarbus longan, also known as mata kucing or longan. So the dots indicate these places where the plant was collected. And now you have software, and it is in fact very easy to use, which looks what kind of climate and soil is present at the places where the plants were collected. And then it starts to look for the rest of Thailand where the same places are more or less also present. And in the end, it produces a model. So here you see the red in this map. So that indicates the land which is suitable for this species. It doesn't mean that the species is there, that you have to check by going there, but in fact, it should be able to grow there. So this is your model. So you more or less then have an idea where this species is occurring. And you can already, for instance, relate it to climate or to soil. So for instance, it is absent in this part because it has a very different soil. It is absent here because here there's a lot of cultivation. So you use climate to make this model. And nowadays you have many climate models to predict what will happen in the future. So you can use these climate models with your climate variables and see what happens in the future. So that's shown in the third picture. You see that, in fact, there will be a reduction in the area where the species can occur, especially in the northeast of Thailand. And the nasty thing is that's the area where they are more or less cultivating this species. So that's bad news. So this is another way of getting some idea what is going to happen to your flora or fauna. Well, back to basics. So we need floras. So we should be able to identify, we should be able to make inventories, monitoring and modeling. And that works, of course, best if a flora is completed. So we have to make a higher productivity in these flora revisions. So we need more scientists, we need more citizen science, and we need innovation. So more scientists is not only the answer, they should also cooperate. And the innovation should help indeed. So perhaps, hopefully, the sequencing and image recognition might help. But what should also happen is that we should not just publish this flora in a thick book, because most people will not use it. So the nice thing is to have it online. So our flora is not really online yet. And if you have it online, you can also produce these apps which people can use. And that makes it all more interesting. Because if you have a book, you can at most have some drawings or some photos printed in it. But online, you can have many, many pictures. So you have a good idea what a plant looks like. Well, Flora Malaysiana, this is the website of it. Coordinating is Daniel Thomas. So he's situated in Singapore. There's one item here which is called Families Treated and Online. So if you go there, you can see which families are already done and where you can find them on the internet. But what you can find on the internet is just, in fact, a scan of the printed pages. So it's not really an online flora. If you have an online flora, it is easier, in fact, because then you can also make changes, because some parts are already outdated. They are more than 70 years old. So then you can change that already to modern insights. If you have a small piece finished, you can already add it and you don't have to wait till a family is finished. So if you have it online, it will be a much more lively item. So that's the whole idea. Get more and more done to see which plants you have present in Indonesia. So don't sit around, just do something, please. So thank you very much for your attention.
Okay, thank you very much for your excellent presentation, I think, because we know that if we want to know deeply about more species, we need to back to the nature, right? So let's move to the time to invite your presentations. Anyone have some question to Professor Peter? Please. Okay, still nuts. Okay, Professor, I'm interested with some techniques during the innovations. In Netherlands, they develop some specific software. The name is Ops Identify, right? So that's software can be
Ops
used
Identify,
in, yeah, it can be used in my country or another country. Is it possible or only in Netherlands?
Well, the software is developed here, but of course it is general. In fact, I think it is even based on Google software. So that is software to recognize faces of people. So it's very general software, and it is just, yeah, what you put in is a number of pictures of plant species in this case. And with that, the program learns what the plant species looks like and how it is called. So it doesn't matter if you use Dutch plants or Indonesian plants for that.
Okay.
It takes more time in Indonesia because you have so much more. Yeah. So
All
hopefully
right.
then it is not too.
Okay, thank you.
So
So
a lot of people in the Netherlands like to use this this app because it is very easy to use, very user friendly, and people are very interested in just the name of something. So, and also if you have the name, you can also press the next button and get more information, where it grows, how it grows, etc. So it's not only the name.
okay, thank you for your answer, Peter. Okay, let me read some questions. There is some question from Mrs. Lisa Lisdiana. Oh no, I think that's only attention over here. Okay, I want to more discuss about some collaborations. Oh, okay. I think Mrs. Lisa first. Okay, Mrs. Lisa.
Okay, thank you for the opportunity. Thank you for your great presentation, Peter. So I interesting for the identification using the DNA. You classify the DNA, the sample for the fresh sample and also old sample. I wondering how old or how long is the storage for the samples that you can classify it as an old sample? Because actually I'm not measuring for the botany or the plant because I also working with the taxonomy, but for the bacteria. So I wondering how old the sample is or how long the storage for the sample, so you can say it's an old sample for the plant that's still able to extract to be used to extract the DNA and use it for the identification.
Well, in fact, most of our specimens, the oldest ones, are from around 1880, and quite often they work well because they have been fast dried. But then you get this period in which they use this Feinsfurt method, so they collect it and put it with alcohol in bags. So those specimens only give very short sequences usually. So with the new method, that works very well. But in fact, there are also examples from permafrost, from for instance, the northern part of Europe, where the soil is always frozen. So animals and plants coming out of that, they still have good DNA. And they even had a nematode which started to become alive again. So I think they're just pushing back the date of the oldest plant or animal which you can sequence.
Okay.
So the same with Neanderthalers, etc. They have their DNA. That is.
Okay, thank you. That's quite old. Okay.
Okay, Mrs. Lisa.
Okay,
I hope
thank
these
you.
explains can explain your situation. Is it?
Yes.
It's clear, right?
It's
Okay.
clear, but actually I want to ask something else, but maybe we have to give the opportunity for other participants first. Okay. Thank you, Peter.
You're welcome.
Okay, all right. So yeah, okay. Mr. Fadlan Muklas Abrori, do you want to ask directly?
Yeah.
Okay.
Thank you so much for the presentation. Mr. Peter, I want to ask, actually, I'm not really understand about the taxonomy, but I ever have an experience with my student. We try to identify some plant with Google Lens. So Google Lens is like an image software to make some, yeah, you can use it for identifying the plant. But the problem is when you want to identifying the plant, you need to focus, for example, in angiosperm, you need to focus in the flower or something like that. And the problem is when we try to identifying like a pteridophyte or fern, or maybe the moss, something like that. So I just want to ask you, how is the percentage, the accuracy in your study using a software about the plant, something like that, using the DNA sequence, or maybe using the image, something like that?
Okay, thank you, Mr. Fadlan. Professor, I think you can answer directly because that is about percentage, right? Okay.
Yeah, well, they're not really percentages. So it also, if you start to identify with an app, then already all these photos of different plants should already be in a kind of database stored, so that the software knows where to look and to look for which characters. So that is usually at the end of the whole project of making a flora. So you first have to know the species, and then you can start to use these apps for identification. You need quite a number of pictures before you get a good identification with one of these apps. What we also often do is called DNA barcoding, and that's something different. I did not explain that. So you sequence a part, and then you have huge databases like GeneBank, and there's another one in Canada. And then you can search with your sequence which species also have this sequence, and then can use that as identification. But here, for instance, for Indonesia, we often notice that the plants are not yet in those databases. So the identification you get is correct up to family level, and if you're lucky, up to genus level, but usually not to species. So for that, you have to go further. You have to see if there's literature available, so you can find these fairly nasty identification keys, these names. Or you have to go to a herbarium and just compare what you have with the specimens which are stored there. So basically, if you have good flora, you can get these good identification apps, and then it will be easier to identify. But it is still progress, and especially for Indonesia, it will still take a long time before we know most of it. So I'm afraid the percentage for Indonesia is not very high. I hope this answers your question.
Thank you so much for the answer.
Okay.
Okay, Mr. Fadlan, does this answer your questions?
Yeah. Thank you so much.
Okay, thank you, Mr. Fadlan. Anyone to have some questions to Professor Peter? Okay, Mrs. Reni Ambarwati, please.
Okay, thank you for the opportunity. Good afternoon, Professor Peter. Thank you for your presentation. I'm teaching animal taxonomy, and well, sometimes we had difficulty with the student because like in this digital era, like everything can be taken by photo, by their mobile easily, the image, and then how can we encourage student to make a herbarium or other preservative materials, because they think that the taking picture is more simple. Thank you, Professor.
Sorry, I did not get the last part. There started to become an echo, so I could not hear the last part of the question. Can you please repeat it? So you have students making pictures of animals, and then you want to have
yes.
identification.
Okay. Sorry, I'll try to repeat my question. how can we encourage
Can you
students?
speak louder? Question?
How can we encourage students to make herbarium or other preservative materials? Because right now in this digital era, they think that taking picture is more simple.
Yeah, I can understand that. Yeah, it needs material.
Okay, thank you.
It needs a lot of material to make an herbarium. So there are two ways you can make your picture, and you can keep the picture. You can also collect plants, and you can also send them, for instance, to an herbarium like the herbarium, and there they can then program. Then you also have to make notes so that there will be a label attached to it. But also, if you make a photo, you still have to see. You still have to make notes where you made the picture, what the surroundings are. So it's important if you make a picture, even that you have more insects will be in your garden, but they will not be in the forest. So that will help. The same with plants. If you just make a photo of a plant, you still have to know where you made it, and what kind of surroundings, because that's quite important also for identification. And then you can collect all these photos and then try to find an identification on the internet, for instance, by comparing it. If you have some idea what kind of group it is, the pictures already available on the internet. But as long as nobody made an app in Indonesia, it will be very difficult to identify from a photo. Also, if you start to use a flora with these identification keys, quite so. And that's the same with insects. With insects, for instance, the sexual organs are very important, but you cannot on the picture. Often you need more than just the picture, I'm afraid. Making a herbarium is not too difficult, in fact. You just have to dry the plant, so you can put it between sheets of paper, newspaper usually, and then you put some weight on it, a thick book. And then every day you just change the newspaper till it is dry. And then you can just glue it to a piece of carton or something stiff paper. And then you have your in fact, a specimen, a herbarium specimen. So as technique, it is not difficult. But only if you do it in large quantities, then you need a lot of paper and a lot of patience.
All right. Thank you, Professor. So, Mrs. Reni Ambarwati, is it clear to answer your questions?
Very clear. Yes,
Okay.
Mr. Fasid. Thank you, Professor.
Okay, thank you. Okay, I will be open one question again before we move. Mr. Alex Sumadijaya, do you want to ask some question directly?
Okay, thank you, Chair, for the chance. Hello, Peter. This is Alex of Herbarium Bogor. It's very glad to see you. Yes. Yeah. My question
I cannot
is.
see you.
Oh yeah.
Yeah, that's better. Hello. Yeah.
Oh, yeah. Well, my question is about one of your slides that explains the Ops ID. Basically, we have tons of other apps hanging around in Google Play Store. And actually, I have my own opinion about this. But what is your opinion about these apps? Are they gonna someday take the role?
Sorry, I cannot hear you well.
Mr. Alex Sumadijaya, could you please repeat your question again?
Okay. Yeah, my question is specifically on these apps, these Plan ID apps that are tons of them in Google Play Store. I have my own opinion about this, but it's really good to get your insight about them. Do you think that someday they're gonna replace taxonomies, their roles, their expertise? We know that right now, everything depends on the algorithm to identify plants as well as their own database. But since we know that the AI is really good at the moment, and with different mechanism of machine learning or even deep learning, they can provide that answer in a very efficient and effective ways. Perhaps we have their own species concept and the limitation. So do you think someday, like, not in a day, not in a year or two, but in the next decades, taxonomies will be replaced by these plant apps, or in general the machine learning method in identifying plants? Thank you.
Okay, thank you, Mr. Alex. I think I got the point from the question.
Yeah,
His question.
me too.
Oh, okay.
Me too. I said no problem.
Okay.
Yeah, I don't think it will replace humans very soon, all this IE, etc. So if you look at this app, it is in fact the end result after the taxonomist has done their work. So all the species are already known, and then you just attach pictures to the species. So in fact, the scientists have decided which are the species, and then that is used to add the pictures and to the app work. So basically, there's nothing threatening about that. It might be that in the future, yeah, more and more things get automated. So for instance, that it is easier to get DNA out of specimens, easier to identify, can be highly automated. And I don't think you even need artificial intelligence for that. Just very good search engines like Google already has. And in fact, it would be nice if IE could take over our role, because then the floor will be quickly finished. But I think it will never happen. It always needs a human to guide it. And most of these apps now use, in fact, flowers and fruits. So if you have sterile specimens, we still have a problem. So I think humans will still be needed, because in fact, we are much better at recognition than machines are. So I hope this helps to answer your question.
Okay.
Yes, thank you.
Thank you, Professor. So, Mr. Alex, is it clear for you?
Yes, and actually I have more things to say, but I think we have reached the end of this session.
Okay. Okay. Thank you so much for your attention. So the time is over from these sections. Let me try to read some highlights from these sessions. We know the plant taxonomy. We will have some three strategies. The first one is about the higher productivity is very needed, which is contained with the more scientists. And second one is about the cooperations, not only scientists in one family. We need more for collaborations. And the last one is about the innovation, which is contained with the molecular techniques such as sequencing DNA and image recognition. So from these sections, I would like to say thank you again to Professor Peter. Maybe I need your time for a while to take a picture together and giving the token appreciations to you. Okay. Okay. Okay, this is the certificates that as keynote speaker today.
Well, thank you very much for this certificate. This is not expected, so thank you very much.
Okay. So for the
it was
photo,
a pleasure to speak. Yeah.
Sure. So for the photo session, I will be give back to master ceremony to hold these sections.
Thank you, Dr. Fasil Bintang Ilhami. Okay, thank you, Dr. Fasi Bintang Ilhami. Please hold a moment so that the committee will take the screenshot as your documentation. Please give your best smile and pose. Now in 3, 2, 1. Okay, please wait a moment. There's still a bit trouble here. Okay, thank you. This documentation is already over. Thank you so much. I will return this session to Dr. Fasi Bintang Ilhami. Time is yours.
Okay, thank you. So, Professor Peter, thank you very much for joining with us in this event in my university. Very much appreciated. And if you have some another activity, you can leave. But if you want to still join with us, also welcome, because I want to move to the next sections. Okay. Okay. I would like to move to Dr. Zoltan Kovacs. I would like to greeting to Dr. Zoltan Kovacs. Hello, Doctor.
Hello, good afternoon in Indonesia and good morning in Hungary.
Yeah, good morning, Doctor. I know the time is about 10 a.m.
Yeah.
right now?
Yes, okay.
Okay. So, Dr. Kovacs, before we start our sessions, I would like to remind again that we have some few housekeeping notes. The speaker will be talk around 40 minutes, and we will have a discussion time about 15 minutes. If you have some question, you can ask your question during the session by raising your hands, or you can type your question in the chat box, and I'm going to read them for you. Well, I would like to read briefly the profile from Dr. Zoltan Kovacs. So, Dr. Zoltan Kovacs, may I call you Dr. Kovacs, right?
No, please call me Zoltan.
Zoltan, okay.
Okay.
Okay, thank you. Okay, so Dr. Zoltan Kovacs, he is Associate Professor in Faculty of Science and Technology, Institute of the Mathematics, Department of Geometry, University of Debrecen, Hungary. And also he is a supervisor following the master and PhD projects. He is already supervised 7 students in the mathematics programs. And the most important thing, that's under the umbrella of Spedium Hungaricum program from the government Hungary, he supervised 1 Indonesian PhD. It's already processed to obtain the PhD degree, and 1 Indonesia PhD student will be start on this September. And his research area is about the mathematics, differential geometry, computer associated mathematics learning and teaching, and in very recently, his research area in pedagogical practice in mathematics education. And the most important thing that he already published more than 60 scientific paper and editorial approach in the high reputation journal. So that's all the profile from Dr. Zoltan. So moving along to our sessions. please welcome to Dr. Zoltan. You have 40 minutes to present your work. Please.
I wonder if my presentation is on the screen or not. Is it okay?
Yeah, it's okay.
Yes, and please indicate if the voice or the audio get wrong, because I had some problems in the previous lectures sometimes. So please indicate this if the audio is not
sure.
okay.
Sure. So, Dr. Zoltan, could you please more enlarge your slides?
I think as I use the preview, it is the best I can achieve. Is it too small?
Not really, but we can see clearly, I think. You can continue.
Thank you. So, good afternoon, everyone. And in the previous presentation, Peter came from a completely different field than me, but we will have something in common. First, Peter talked about mathematical models. Second, in Peter's presentation, there was also tradition in the form of old herbaria and modern innovations such as molecular biology. We will continue with the relationship between tradition and innovation in a completely different field. So here the picture on the right is taken from a Hungarian math textbook from the 70s, not in use today, from the 70s of the last century. There are two happy pupils engaged in solving a mathematical problem, working in pairs, and perhaps discovering something exciting and important about fractions. Exactly the image that lives in my mind about math learning. So let me start with a personal story. Once upon a time, during my early teaching years, I spent a lot of time teaching geometry to prospective math teachers. During a lesson, one of my students drew the cartoon shown in the slide. Looking at it, I fit the stereotype of the math professor, glasses, white coat, and funny haircut, not the way you see me today. And my approach was also extreme classical. I gave, in my opinion, brilliant lectures in the usual definition theorem proof system. But one day, however, a strange thing happened. One of my best students fell asleep during my lecture. You may imagine it was a shock and an existential crisis. Was my lecture that boring? Have I lost my charm? Whatever the reason, I knew it was time for a change. Then I remembered how my favorite professor used to give his lectures. 3/4 of the time, he would narrate, and then about a quarter of time, he would summarize the material he had covered. It was always a story about the syllabus, but it set the stage, this narration set the stage for the traditional definition theorem proof structure. I also remembered George Poya's works on mathematical problem solving, which I had liked because of the mathematical problems. I wondered if I had missed the central message of these works, which was how to look at mathematics and how to think mathematically. I do not know how familiar my university professor was with Poya's works, but what he was doing was exactly what Poya emphasized. Mathematics has a double phase. The stable and irrefutable deductive phase is accompanied by a temporary, sometimes unstable inductive phase that gives rise to mathematical discoveries. Mathematicians are well aware of this phenomenon, but the incredible realization is that this inductive phase can be included in teaching mathematics. And I also remembered an innovation of the Hungarian educator researcher Tamás Varga, who often used a dialogical form in his mathematics textbooks. I was also clear that these two ideas would go well together, presenting the inductive side of mathematics as a cognitive activity, and the dialogue with students as a kind of social activity. In the end, I began to organize my lectures similarly, making my classes interactive, often dialogic, and I hope at least as successful as before. And they lived happily ever after, as the fairy tales say. So what happened to my teaching style? Early in my career, students were mostly passive recipients. This has been replaced by a teaching style based on active student participation. The concept of active learning is a large umbrella over many components. On the slide is a widely accepted definition. Active learning engages students in the process of learning through activities and discussion in class, as opposed to passive listening to an expert. It emphasizes higher order thinking, so cognitive activity, and often involves group work, dialogues. The inductive type activities and the discussion in the classroom are two of components of the active learning. This concept brings us to the central question of today's talk. How does the inclusion of inductive side of mathematics in mathematics classroom and the use of dialogical methods support active learning? Join me as we investigate and conclude. Hungarian-born George Poya, or Poya György, was one of the most important classical analysts of the 20th century, whose influence extended to number theory, geometry, probability, mathematical physics, and combinatorics. In mathematics education, Poya is best known for problem solving. What mathematics educators focus on most is how to solve it. It is from 1945. So in how to solve it, Poya expanded the notion of heuristic strategies as a critical aspect of mathematical thinking. Poya emphasized the importance of structuring the problem before diving into the solution. Heuristics, such as thinking backwards, using symmetries, or drawing diagrams, make complex problems more accessible and solvable. Metacognition refers to the awareness and understanding of one's own thought processes. Poya emphasized the value of reflection and self-assessment in the problem-solving process. According to Poya, an interesting curriculum and challenging problem is the fundamental driver of motivation, and mathematics become truly fascinating and engaging when taught with passion and in real life context. And active learning involves students active engaging with the material, participating in the learning process. So Poya drew a parallel between active learning and active teaching. Poya formulated the active learning principle. For efficient learning, the learner should discover by himself as large a fraction of the material to be learned as feasible under the given circumstances. In parallel, from the teacher's perspective, the principle is let the students discover by themselves as much as feasible under the given circumstances. Today's understanding of active learning is also in line with Poya's principles. University math lectures and university math textbooks often present the demonstrative phase of mathematics. It is safe and final. Remember the opening story. That is how I started my teaching career. And if I am being sarcastic, that is what put my best student to sleep. Active learning requires students to be active participants. However, the student does not yet know the end result, but must engage in a journey of discovery. It is through discovery that the plausible phase of mathematics is revealed. Plausible reasoning is provisional, perhaps not final, perhaps controversial, and even it is dangerous. Why? Why is plausible reasoning dangerous? Poya compares rigorous demonstrative reasoning schemes with plausible schemes. There are one-to-one examples on the slide, but there are many others in his books. On the demonstrative side, there is a definite statement, A is false. If A implies B and B is false, then A is false. On the plausible side, there is only that A is credible. So if A implies B and B is true, A is credible, but who knows A is true or false? And the plausible inference schemes are typical in reasoning in science. Poya himself emphasized this. By applying these schemes to mathematical reasonings, Poya placed mathematics among the natural sciences, such as chemistry, biology, and physics, and I like very much this idea. On the other hand, plausible inference does not provide real proofs in the classical sense. Perhaps this is why it is avoided in mathematics classes, as Rina Haskovic claims. Poya did not conduct empirical research in the modern sense, although he often referred to his course experience. In his books, he gave many examples of possible paths to discovery. He begins his discussion and induction with a simple example, the Goldbach conjecture. He introduced two constructs, suggestive and supporting contact. I like this term very much because the word contact refers to the interaction between the learner and the mass. You could say also collision as physicists. So the learner first just pays attention to the problem, then goes deeper. Suggestive contacts were the preliminary observations. These interactions prompt a person to a particular thought or belief. Suggestive contacts subtly guide one's thinking or behavior in a specific direction without direct instruction. Observations such as pique interest. On the left-hand side are primes, prime numbers. And on the right-hand side are even numbers. Nothing special. If you add two odd numbers, you get an even number. But the interesting thing is that these even numbers are some of prime numbers, not simply odd numbers. So it is interesting. Boya does not explain precisely how this phenomenon occurs, but in a classroom setting, it is obviously the teacher who can draw attention to it. And now some other questions appear. What about other even numbers? Do they behave similarly? Trying some other numbers, one may believe that any even number greater than 2 is sum of two primes, prime numbers, which is a conjecture. By the way, it is a famous conjecture known as the Goldbach conjecture. You should not put too much trust in any unproved conjecture, Boya said. And one arrives at the supporting contact phase. We are already interested in the topic and now looking for support or counterexamples. The supporting contact phase refers to the interactions or experiences that reinforce or refute existing beliefs. Supporting contact may strengthen confidence in a previously had conjecture. One can proceed systematically in many other cases. A general conjecture statement becomes more credible when it is verified in a new case. Boya's approach is that one can distinguish two groups among the particular cases, to those that preceded the formulation of the conjecture and those that followed. The former suggested the conjecture, while the latter supported it. Both types of cases provide some contact between the conjecture and the cases studied, that is facts. Sooner or later, we must move to the deductive side of mathematics, and the conjecture supported by examples and experience must be proven. In the specific case of Goldbach conjecture, no one has succeeded so far. Of course, the Goldbach conjecture is only one example from Boya's books. Nevertheless, it shows excellent pedagogical sense on Boya's part to include it among the examples. Hungarian textbooks also use it because it is a reasonable basis for problems when students learn about prime numbers. It is also a good opportunity to introduce students to an unsolved conjecture. It is also a sound basis for inductive reasoning. And because there are often several solutions to a given even number, it is also a problem for differentiated learning. Finding solutions requires algorithmic thinking and can be a task for writing program. We can continue the interesting series of problems starting with the Goldbach conjecture. Remember Boya's advice, the best motivation is an interesting task. It is also historically interesting, so it has an engaging effect, even for human-interested students. On the slide are Boya's words about the so-called inductive attitude, which I tried to summarize earlier. Inductive attitude requires intellectual maturity to challenge and revise beliefs, intellectual honesty, not to cling to contradicted beliefs, and wise restraint not to change beliefs without reason. The most important lesson of these words is critical thinking as one of the most important features of science. At the end of the first part of my talk, I would like to add another quote from Poya, which also summarizes my view well. And so I hope, Poya said, that mathematical discovery and the inductive aspect of mathematics will not be so completely neglected in the high school of the future from 1965. Recently, at a research seminar, I showed this slide to young researchers from all over the world and wondered what they would say to Poya if he came into the room. Please formulate your own message to Poya. Now the second part. As I quoted earlier, Alan Schoenfeld wrote, Poya is the giant on whose shoulders we stand. Our next scholar for today's talk considered himself a follower of Poya. The transition of novel principles into concrete mathematical teaching practices at the country level is entrusted to teaching professionals with excellent theoretical knowledge and a strong practical sense. Tamás Varga was such a type of scholar. He was one of the prominent figures in the history of Hungarian mathematics education in the 20th century. He led the so-called complex mathematics teaching experiment, which aimed to renew the content and the methodology of mathematics teaching in Hungary. The complexity of the reform means that it concerns the curriculum, task design, resources, and indications of expected teaching practices. The principles of the experiment were eclectically drawn from many places, trying to keep the best from each, as one of his collaborators said. Poya and Varga both stress that abstraction stems from concrete experience. Varga believes effective abstraction requires familiarity with varied concrete situations, transitioning from operation with things to operations with signs. Varga's use mirror Piaget's cognitive development theory, which posits that learners actively form new ideas based on prior knowledge. Brunel's theory, outlining a progression from hands-on experience to abstract thought, complements Varga's approach, starting with hands-on and active, moving to visual, iconic, and ending in abstract, symbolic understanding. Additionally, Varga highlights collective classroom dialogue for problem solving. In this approach, the teacher, mirroring Vygotsky's social learning theory, acts as a guiding figure during collective exploration. One finds the following material in the 6th grade textbook written under Varga's guidance, not in use today. Unlike traditional textbooks, which often present information in a unidirectional manner, this fragment contains a dialogic format that mimics classroom conversation. The topic is operations with negative numbers. The textbook problem is increment 12 by 7 in two ways. By addition, it is very easy add 7 to 12, and also by subtraction. And the picture is a character from the textbook. The girl's name is Yuli. So, Yuli said in the textbook, "Don't you think this is very strange? I subtract something from a number, and the difference is greater than the number I subtracted from." Here is the peer's answer in the textbook, another character from the textbook, Miklos. "If you subtract a positive number, it is impossible. But the smaller the number you subtract from something, the bigger the difference. Just look at operations below each other. How regularly do the last three lines follow the lines before them?" By analyzing the dialogic structure and content, we can identify several possible functions and pedagogical strategies that are consistent with Vargas' approach. Yuli's initial confusion about the subtraction of negative numbers was a common starting point for students to grapple with this concept. Miklos' response offers a step-by-step explanation based on inductive reasoning here. Miklos used a pattern to illustrate the subtracting a negative number resembles an addition. 5 plus 1 equals to 6. By using the voice of the peer rather than an authoritative figure like teacher, the dialogue might facilitate more relatable and accessible learning. Although the teacher's voice is absent from the dialogue, the structured discussion reflects a possible classroom implementation, provoking cognitive conflict and using patterns. The dialogue represents a mathematical concept and models an inquiry-based, student-centered pedagogical approach. The teacher can see this dialogue as the optimal realization of the active knowledge construction. In a real classroom, this dialogue is unlikely to happen in this way, but the teacher can try to guide these nodes to emerge. The dialogue continues in the textbook, but I will stop here. I hope this gives you a flavor of the textbook concepts. So, what is the purpose of dialogue for? From the student's point of view, the use of peer's voice rather than an authoritative figure's voice may be more conducive to learning. And from the teacher point of view, the dialogue models an inquiry-based, student-centered approach. No, and a short
ICoMaSEdu paper ya. PPT ya.
Pardon?
Sorry, Dr. Zoltan.
Okay, I thought it is a question, but I realized that
okay, sorry.
Really not. Oh, thank you.
Okay, sorry. You can continue again.
Okay, so when you look at the world through the lens of inductive reasoning, you ask students questions like investigate and conclude. I will now present an example from today's Hungarian mathematics textbook for 7th graders and its real implementation in a real classroom. The task is investigate the decimal fractional form of a fraction with denominator 99. Use your calculator to do calculations. write down some examples in your notebook. Draw conclusions from your experience. In the original problem was the denominator 99, but the teacher in my classroom introduced the treatment of the problem with a more straightforward question, fractions with denominator 9. So she simplified the task as a first phase. It is more straightforward. What has happened? In the first phase was individual work in which students worked on examples according to Poya's suggestive contact phase. So just contact with the problem. The students did some calculations, 1 or 2 or 3, and after individual work, the following conversation took place during the class discussion. So here are some examples. Tommy, a boy. If A is a digit, then A over 9 equals 0.AAA, that is 0.A. It is a conjecture based on the examples in the preliminary phase, so based on suggestive contact. A girl, Lusa, I got a different result for 8 over 9. She doubts. What is your different result? Lusa said, I got some 8s, but at the end 9. Others, the calculator is rounding. And the teacher's answer, this is possible, but maybe Tommy could be wrong. How would we check it? And after that, the supportive contact phase, Gobi. We will try it by hand, and there are a few cases, only a few cases to check. They check it, and they are convinced. But here is Andy. How Tommy's conjecture fails when A equals 9. Why 9 over 9?
Excuse me, Dr. Zoltan.
Yeah.
Your time remaining 5 minutes again.
Pardon?
Your time still remaining 5 minutes again for presentation, because you have 40 minutes for presentation.
Yes, and in my oh yes, but I began it 28 minutes ago exactly, because I measured the time.
Oh, sure.
Thank you. So the teacher answers, since we cannot tell how much 0.8 is less than 1, it is common to say that it equals to 1, strange as that may seem. So the above etude also represents well Vargas' principles. One of them is that the curriculum should include material relevant to mathematics that is also exciting or surprising for the learners. The representation of rational numbers is the cornerstone of arithmetic. So the problem presents a big idea of mathematics, both decimal forms of the fractions with denominator 9 and the issue with 0.8 are surprising results. Surprising facts are motivating for most learners. The mathematically flawless explanation, this issue, is based on the result of the sum of geometric series. However, this explanation is not yet available for 7th graders. The students faced a new and familiar problem, starting with a simple task. The teacher prepared for this outcome and used Rózsa Péter's, another famous Hungarian mathematician, explanation in the famous book, Playing with Infinity. So it is common to say that this equals to 1. The attitude toward the problem must not be, we have not learned this yet, but to strive to solve the difficulties. And the final part, I try to shorten, but in my measure, I have time. So in 2016, the Hungarian Academy of Science launched a comprehensive research program focusing on the teaching learning process. The goal was to propose scientifically sound interventions to achieve the desired educational outcomes. One of the research groups I was part of worked on the teaching and learning of mathematics, and one of its goals was to revive Tamás Vargas' legacy. We captured the essence of Vargas' legacy in the incorporation of problem solving, including the teaching and heuristic strategies, the use of pair and group work, the incorporation of discursive elements in math lessons instead of teacher-centered presentations, where the teacher's role is to stimulate discussion and as a result to incorporate students' ideas in the lesson. Here is the scheme of our personal development program for teachers. And we summarized our result in some papers. So the analysis concluded that teachers in the program understood the nature of problem-based teaching style and made efforts to change their teaching habits. However, they were not always successful in implementing these changes, especially when faced with unexpected situations in the classroom. So in the next phase, we looked after these unexpected events in the classroom. A recent paper, it has appeared in August in Learning and Instruction. So when employing problem-based learning in math, teachers frequently face unexpected mathematical events which can be mishandled in the classroom. Our study, rooted in cognitive load theory, suggests that teacher responses to such events are influenced by three factors: the demand of the unexpected event, so it is an intrinsic load in the brain; load from irrelevant factors, there are external load, for example, a noisy classroom; and available cognitive resources, teachers' cognitive capacity. So our finding is that without proper schemes, teachers risk overlooking valuable students' input in the classroom. So building the schemes supplemented by continuous self-reflection and understanding diverse students' responses can diminish intrinsic cognitive load. Linda Devi Fitrian, a Stipendium Hungarian Scholarship recipient, I hope she is here in our room, from Indonesia, examined mathematics teaching and learning through the active learning lens. She found that challenging and interactive environment boosts engagement and learning quality for prospective teachers in Indonesia. Key elements include problem posing, reflection on teaching, and peer feedback. This research aimed to enhance the skills of Indonesian prospective math teachers by involving them in problem posing, collaborative problem solving, and discussions. They also tested their self-designed problems in real classrooms, followed by self-reflection and peer feedback, supporting the current Indonesian curriculum. So, a coda for my lectures. Breaking news that just I was preparing for today's talk, I came across an article in a Hungarian newspaper. In the global market for architectural design software, a Hungarian company has achieved a leading global market share. Its founder recently published an article highlighting the strong correlation between economic development and the level of public education. He uses examples to illustrate the extraordinary opportunities that the information revolution could bring to Hungary if the country builds on its once world-renowned tradition in mathematics education. As we consider the future of mathematics education, let us be inspired by this vision and recognize the potential in reconnecting with our educational heritage and embracing modern technological advances. Moreover, I strongly believe that this tradition is worth spreading and that the Hungarian-Indonesian cooperation in the field of mathematics education will be really fruitful. Let me conclude today's talk with two iconic bridges. On the left is the famous chain bridge, the symbol of Budapest, the capital city of Hungary, which represents the tradition in today's context. The Suramadu Bridge on the right is well known to today's audience, and of course it represents innovation. I hope that these two bridges will be connected symbolically in our minds and also physically in physical reality through people. Thank you. That is all.
Okay, thank you so much, Dr. Zoltan. I think very interesting presentations because you provide several technology in the mathematics educations. So now it's time to invite your participations for discussions. Anyone to have some questions to Dr. Zoltan, please raising your hands.
So there is a question in the chat window.
Oh, yeah.
To what extent we may incorporate technology in the students' learning? I saw several usage.
Okay, of technology.
Oh yes, here is that. Yeah.
It's
Thank you.
here, Dr. Zoltan. So I want to read for you. To what extent we may incorporate technology in the student learnings? I saw several usage of technology in your talk, like the use of calculator. However, the student
and
also
programming
needs,
also, yes.
To work actively and discover the mathematics by themselves, unless we let the student to heavily rely on the use of the technology. So, Dr. Zoltan, it's time for you to directly give some answer for these questions.
So thank you for this really great question. And just 3 weeks ago, I delivered a seminar for young researchers, and in this seminar I dealt with this question for 2 hours, I think. So it is a very interesting question. So I think that technology is a big opportunity, a great opportunity. So educational technology, and I mean mathematical softwares, not general technology like a presentation or something like this, but really mathematical softwares, mathematical technology like calculator, GeoGebra, Wolfram Alpha, and other technologies. These technologies have a great opportunity. And 10 or 20 years ago, we thought that it will be the future. But the reality is something different. However, we have great possibilities in real classroom situation. The application of these technologies is not so common. So it depends on many facts why teachers in most countries really not use effectively the technology. But I think one of today's most important research area, how to find the way of these technologies to the classroom. So how to implement these technologies in a pedagogically sound manner in the classroom. So we have great opportunities, and the practice is not so convincing today in most countries. There are some really valuable experiences, but not the average. I do not know really what is the concrete situation in your country, but the experience vary generally. So can we use in technology? It is another question. Can we not use but rely on technology? The most important thing, which I emphasized also in my lecture, is critical thinking. Use the technology with critical thinking in your mind. So even a pedagogically sound application in the classroom may imply some issues, and you should evaluate it critically. In my presentation, the interesting fact with 8/9, it was an example, and why 0.9 dot is equal to 1 is another. So shortly, it is my brief answer to the question, and I ask Sofan whether it is right answer for you or not.
Okay, Mr. Sofan, could you please open your camera?
Okay, yes.
Okay, does this answer your questions, or do you want to talk more detail about these explanations to Dr. Zoltan?
Yes, thank you for the opportunity. So in my what I heard is about we can still use the technology in inviting the student in learning mathematics, but still we highlight about the critical thinking. So don't let the technology like become reliable until the student come to their critical thinking first. I think that's what Dr. Sota tried to say, and I want to understand.
Okay.
Thank you. Yes.
Okay. Thank you.
It was my point. Thank you, really.
Yeah,
okay.
So the next question.
Next question from
ICoMaSEdu.
From Mrs. Rini Setianingsih. They contain with the 4 point over here, Dr. Zoltan. First point is about, first question is how to create a classroom environment that can be facilitates active learning. Then second question, what are the role of teacher during the instruction implementing active learning? And third one, in Indonesia, students study a wide variety of mathematical materials. What are the characteristics of suitable mathematics material to be taught using the active learning? And the last one, what is the form of interaction in implementing active learning in class?
Yes, very interesting question, and thank you very much for these questions. I reported a classroom experiment in a real school in my talk, and the idea was exactly the same. Do not change the curriculum. Do not change the teacher's agenda, but implement active learning in the usual agenda, in the usual curriculum. How? Our idea was that this problem-oriented approach is the possible way to active learning. So there are many problems in textbooks, and with small alterations, these problems can be altered that are suitable for problem solving. So the basic is for the active learning and how to create a classroom environment. You need right problems in the mathematical problems in the problem. So not only procedural knowledge, but a deep understanding of concepts, so problems. The second is the opportunity to argument discussion with peers, adapt to peers and follow explanations. The second one is the discourse, the argumentation in the classroom in the form of pair discussion or whole class discussion. And the third thing is critical thinking. So you can critically evaluate your process and the peers process. So it is, I think it was the three main components: problems, critical thinking, and argumentation. What are the roles of the teacher during an instruction implementing active learning? Yes, it is the crucial point. As I said, an active learning classroom, first of all, it's very noisy, and it is an extraneous load for the teacher, and many unexpected events appeared. So the teacher can not too easy to adapt this situation for the teachers, and even they have the knowledge how to drive the lecture in active learning way. The real practice is very demanding for the teachers. It was in my lecture one of the last research about cognitive overload of teachers. So the teacher first of all guides students, so the students are not alone. They need a guide, an experimented guide, but this behavior of guide is a very, very demanding task. In Indonesia, students study a wide variety of mathematical materials. What are the characteristics of suitable mathematics material to be taught using active learning? So there is no limit. The only limit is the teacher's limit. So if the teacher is innovative and well prepared, then everything can be taught in active learning way. I believe this. What is the form of interaction in implementing active learning class? Yes, interactions has many forms. First of all, my favorite process is that in the first stage, every student should be acquainted the problem alone. So the student should understand the problem. The student should place the problem in his or her knowledge It is the first phase. So interaction with the self. And second, with peers. So interact with peers and discuss the problems. And the next step is interaction in the classroom with other peers, with the teacher. And it is the final stage, I think, when the teacher guides the students in the right direction, and the final conclusion is drawn in the classroom. So thank you again for your question.
Okay, thank you so much, Dr. Zoltan. So, Mrs. Reni, is it clear for you for answer? Okay, Mrs. Reni.
Okay. Thank you very much for the answer. I can understand the explanation of Dr. Sultan Kopa. Thank you.
Thank you so much. Thank you so much. So the last question is come from our FIS Deans, is Professor Roselina.
Yes, yes.
She
wrote a
mentioned
joint
that,
paper
yeah,
with Linda, Rosalina, and me, and
yeah.
it was about problem posing of Indonesian and Hungarian students. It was a cross-national study. It was, I think, it was a really interesting research and interesting paper. Yes, so Rosalina put the point of the cognitive resources of students. I think I am interested in inductive attitude. Our Indonesian students have positive attitude toward math. However, the math competence is low. Yes. How to improve students' inductive attitude in learning process? So, different students have different math competencies, and develop increasing math competencies is always our aim in mathematics. So not the knowledge of facts, but attitude and other competencies. So I think that the math competence is a thing which can be increased. So the right order is not that competence and then inductive attitude, but the reverse. From inductive attitude, we hope that this inductive activity and inductive attitude will enhance mathematical competencies. You know, what is difficult in mathematics? For example, proof. Proofs are difficult. Argumentations are difficult. There are logical schemes and so on. But if the first step is not the proof, not the deductive part of mathematics, but the inductive part of mathematics, then even the not so good students can got some positive experiences. So I think this inductive attitude goes together with positive experiences, because this phase is before the deduction, the hard part, before the hard part. So this is my idea, but it is a good point for research. Rosalina, thank you. This really deep question.
Okay.
How to improve students' inductive attitude in the learning process? Yes, first of all, you need students who are interested in mathematics, of course. And I think that there are many facilitators for increasing this interest. First of all, we did a research recently. The teachers' supporting attitude, mathematical support and social support, will increase even mathematical aptitude. It was a great discovery, I think, recently. So we investigated not so good pupils in mathematics, and what about their attitude about mathematics. And the most important factor is the teacher. It was our findings. Our finding.
Okay, thank you so much, Dr. Zoltan. Hopefully this answer can be clear to solve the problem from Professor Rosiliana. Okay, Professor mentions thanks a lot to Dr. Zoltan also. Okay, Dr. Zoltan's, because time is over, so maybe I need your time for a while to take a picture and giving the token appreciations. And for this moment, I will be give back to master ceremony to handle the sections.
Okay, thank you, Dr. Fasi Bintang Ilhami. Please hold a moment so that the committee will take the screenshot. Okay. Please give your best pose and smile. Now in 3, 2, and 1. Okay, thank you. This documentation session is over. I will return the session to Dr. Fasih Bintang Ilhami. Time is yours.
Okay, thank you. So, Dr. Sultan, I would like to say thank you very much for your joining with us with Universitas Negeri Surabaya as my university, and very much appreciated. And also perhaps we can see you in Indonesia, especially in our university. Please welcome anytime to come over here. And before we move to the next sections, if you have some another activity, you can leave. But if you want to still join with us, also welcome, Dr. Zoltan. And for the all audience, thank you very much for being a wonderful participants during these sections. And well, I will be give back to the master ceremony to continue for another sessions. Thank you so much.
Thank you so much, Dr. Kovac.
Thank you for this great opportunity, and thank you for all the audience, and thank you for the questions.
Thank you, Professor Peter and Dr. Kovac, for that insightful session. I'm sure we have all gained a lot of knowledge and understanding for all the presentation. Also, I would like to thank you to Dr. Fasi for hosting this session so well. Let's give them another round of applause for their excellent presentation. And to all presenters today, you can feel the attendance stats. And for presenter today, you can fill the attendance list that's sent to you directly in your chat box. Don't forget to fill it. Ladies and gentlemen, please, attention. We are now continuing our meeting to hear the keynote speech, which will be delivered by Professor Sir Martin Polikov from University of Nottingham. This keynote speech session will be hosted once again by Dr. Heri Wijayanto. To all the participants, please turn on your camera during this session. Ladies and gentlemen, please welcome Professor Sir Martin Polikakov and Dr. Heri Wijayanto.
Okay, thank you again, Anisha, Master of Ceremony, for your short introduction and for your time. So good afternoon, everyone, here with me again. So I would be moderating for the last keynote speaker, which is his name is Professor Sir Martin Polyakov from the UK. So I think it's he is already here. So Prof Martin, good morning in the UK. Hello, Prof Martin.
I'm sorry, I had my microphone off. So good morning, everyone.
Oh, yeah. Thank you so much. Good morning and afternoon in Indonesia, in Jakarta time.
Good afternoon.
Okay, so you are in the last session as a last keynote speaker. So how do I call you? Professor Martin, is it okay?
Yes, or just Martin.
Okay. Okay, so I would like to introduce you, Professor Martin, to the participant. So I don't know how to read your CV efficiently because it's quite long with so many achievements, but we try to make it as simple as possible. So Professor Martin is a research professor in chemistry at the University of Nottingham, and he got a bachelor's degree at the King's College, Cambridge in 1969. So this university is currently known as the University of Cambridge, if I'm not wrong. So, and he got a PhD degree at the same university in 1973. And he received so many honors and awards from, for example, prize from Royal Society of Chemistry. And then he was also elected as a fellow from Royal Society of Chemistry, as well as from the Chinese Chemical Society. And he was also awarded for science communication for his work on the periodic videos. So this is the fun fact of him, that he is actually a YouTuber. You can check his YouTube video, namely periodic videos. That's the channel. And I actually subscribed your channel already since 10 years ago. Yeah, that's quite long. And so it's great honor to have you here to interact with you directly, even though via Zoom. So his research area is about chemical application of supercritical fluids and metal oxide nanoparticle and so on. And he published more than 100 scientific papers in a high reputable journal. So that's all the introduction from Professor Martin. And before we get started to hear a presentation from you, Professor Martin, I'd like to remind you that you will have 40 minutes to talk.
Yeah.
Then continue to Q&A session for 15 minutes.
Okay, I will try not to be too long.
Okay, thank you. So, okay, now time is yours, please.
So I will share my screen.
Okay,
so
that's clear.
Can you see that okay?
That's okay.
So this is the title of my lecture, and I'm from University of Nottingham in England. And so my talk is really about the periodic table, which was published by Mendeleev just over 150 years ago. And the aim of my lecture is to show that Mendeleev's genius, his really great idea, was to create something that anyone can use as a highly flexible framework for expressing their chemical ideas. And over here is my favorite portrait of Mendeleev. It hangs in the Russian Academy of Sciences. You can see he's drinking a cup of tea. And interestingly, he is holding a cigarette. Apparently, Mendeleev always wanted to have his portraits with a cigarette in it. But I like this because it looks as if he's going to say something interesting. And the way I'm going to demonstrate my aim is by giving you a tour of my office in Nottingham. So this is the entrance to my office, and you can already see that there are several periodic tables. But if we go into the main office, which is inside there, I have on the bookshelf a Russian Soviet stamp, postal stamp, that was printed in 1969, 100 years after the periodic table was published, and it has on it a picture of Mendeleev's original periodic table. Now, you do not need to be a chemist to understand this lecture, but for those of you who are chemists, like the moderator Hiri, it is interesting that the first periodic table is on its side. The elements go across rather than down in the first version of his periodic table. So you can see hydrogen and so on, and then the periods go down and the groups go across. And next to my desk, I have this photograph, which is of the oldest surviving periodic table that you could buy to hang in your lecture theatre. And Mendeleev, when he published his first periodic table, predicted the existence of elements that had not been discovered. And we can use that fact to date this periodic table because there are 3 elements here, scandium, gallium, and there's a hole here because the element germanium had not yet been discovered. And from the dates of the discovery, you can see the periodic table must have been printed between 1879 and 1886. And we believe it's from 1885. And on my bookshelf, I have my first inorganic chemistry book that I had as a schoolboy. And this was published in 1961, but really surprisingly, there was no periodic table in it. So my parents bought me a periodic table, and this is my first periodic table that my parents bought me. It was really in 2 parts. There was this one, which is quite small, and a much bigger version, which I hung on the wall of my bedroom. And I don't have a periodic table hanging in my bedroom now, but if you look at this periodic table, it is much the same as the modern one, except the element argon here has a symbol A, and later it was changed to AR. And the periodic table finishes at element 101. There are now 118 elements known. So in my lifetime, since my first periodic table, 17 new elements have been discovered. Then I also have this very strange periodic table hanging in my office. And this periodic table shows all the natural elements, the ones that are not radioactive, but it shows from the area of each of these how much of the element is available on our planet. And it is on a logarithmic scale. So some of the very rare elements like francium and radium down here are much bigger than they should be. But the elements that in green are elements that are very abundant and will never run out. And then going from yellow to orange to red are the elements where the supply is really quite short. It may run out quite soon. And if you look, you can see here there are little white symbols which are meant to look like a smartphone. And the this shows all the elements that are found in a smartphone. And some of them are in very short supply. For example, indium here is used in the screen of the element of the phones that you're using. So there are 31 elements in a smartphone, or perhaps even more if you have an expensive one. And this means that when you carry around a phone, you have nearly or more than a third of the periodic table in your pocket. And so chemically, a smartphone is very interesting. But the problem with the periodic table here is that it doesn't show you whether an element is a gas or a metal or a liquid and so on. And to solve that problem, you need to look at my ties. And in my office, you can see there is a big display of ties, including the tie that I'm wearing at the moment, which is here. But the tie that's important is my tie on the right, which is in Chinese. And I don't know how many of you can read Chinese, but Chinese characters are made up of different parts called radicals. And the elements have a part which you can show here is outlined in red, which means a gas, or this part in green, which means metal, or the part in yellow, which means stone, which means it's a solid, but it doesn't have metallic properties. It doesn't conduct electricity. So now if you look at this part of my tie, you can immediately see that those elements are gases. And these elements are metals. And these ones are solid, but they're not metals. So I persuaded my friend David Cole Hamilton, who made that periodic table of the abundance of the elements, to produce one in Chinese. So here's exactly the same periodic table, but in Chinese. And now you can see that 5 of the most abundant elements on the planet are all gases. And I think that's really good. So you can see just by changing from one language to another, you can put a whole load more information onto the periodic table. And if you're interested, you can get copies of these periodic tables from the ICoMS, the European Chemical Society website. You can just download them. So this is a modern periodic table, and you can see it looks as if it is completely full. Every square is nicely filled with an element, from number 1 hydrogen here to 118 organeson at the bottom. So I like this periodic table, but it does give the impression that that there's no room for new elements. But there's a different sort of periodic table that was discovered by the the English chemist called Charles Janet. It was not discovered, but he produced this design, which has conveniently a space at the end for elements 119, 120. But you can see this design of periodic table is very long, and there isn't room for it in my office. So I don't have this periodic table in my office. I just have a picture of it on my computer. Then one of our biggest YouTube fans, a teacher in Japan called Nagayasu Nawa, has put Charles Janet's periodic table onto a fan, which is very nice if it's hot. And there is space down here for elements 119 and 120. And Nagayasu Nawa has also made a most amazing clock. And this clock has all the elements going around from hydrogen number 1 here, all the way round to element 60 here, and then going round again to element 120. Now, the reason why this is really useful is because most chemists, including me, cannot remember the atomic numbers of most of the elements. But most chemists, at least those who are from the adults now or beyond students, can easily read analog clocks. So if you look at this clock, many of you will be able to read that it's showing the time of 11 minutes past 10. So you can just look, and this is pointing at the element sodium. So immediately you can say sodium is number 11, and lutetium is number 71. That is 60 plus 11. And if you look on this side, it is pointing at 51 minutes. So antimony here is element number 51. And beyond it is the element with the symbol Rg, which has the most difficult to pronounce name on the periodic table. It's called Röntgenium. And you can tell that that one is element number 111, that's 51 plus 60. So is that okay? Wave your hands if you understand that's okay. So I've then got a whole series of quite funny periodic tables. The year 2011 was the International Year of Chemistry, and the Royal Australian Chemical Institute paid artists to paint a picture for each of the elements. And in my office, I have the picture for element 31, which is gallium. And this picture is quite clever because it is a joke in 3 different levels. And the reason why it is a joke is because gallium was named after France, and the chicken or cockerel is the symbol of France. But the Latin word for a chicken is gallus. So this is a joke making a connection between gallium and the chicken. And the final joke is that the element was discovered by a chemist whose name in French was le coq, which is the French word meaning a cockerel or a male chicken. But I was always a bit mystified why there was a radioactive symbol up here. And eventually I looked at the website and it said radioactive gallium could be used in medical purposes. But it turns out that there's a much more interesting reason why they could have put radioactive symbol there, because I don't know how many of you have seen the film Oppenheimer. Have any of you seen the new film Oppenheimer about the atom bomb? And this is one of the pictures from the trailer, and it shows them assembling the plutonium bomb. I put this in inverted commas because it's not the real bomb. But if you look at the design of this bomb, which here are the engineering drawings, right in the middle, there was a ball of plutonium. But plutonium, it turned out, was a very difficult metal to make into a sphere. So it was discovered that if they added a small amount of gallium to the plutonium, it made it much easier to manufacture. So the first plutonium bomb contained a small percentage of gallium as well. Now, on my wall, I have a number of periodic tables that are really jokes. This one is the periodic table of vegetables. And it has all sorts of vegetables, but the vegetables don't really have a connection with the element. So, for example, down here is tantalum, but there is a tomato because TA looks a bit like tomato. And then along here is PO, which is potato. And I really like this periodic table, but it's because it's a nice picture, but the students find it very confusing in my office. And on the bookshelf here, I have, you can see my room is very crowded. There is this small container, and this contains the world's smallest periodic table that was engraved by our nanotechnology center on one of my hairs. And this is the page from the Guinness World Record 11 years ago, showing that it was the world's smallest periodic table. And nearby, I have a piece of Russian soap, which was a souvenir for element 118, which was named after the Russian physicist Yuri Gagarin. And he is the only living person who has an element named after him. And here is Yuri Gagarin sitting in my office, holding the hair with the world's smallest periodic table on it. And that was on the 13th of March, 2019. And I have to be honest, 2 hours after I took this photograph, my colleague Andrei gave Yuri Gagarin a smaller periodic table. You can see not much more than 10 microns across, that was engraved on a piece of silicon. But this is a very good warning to all of you that if you make something like this, you should check the spelling of the words. And he has spelt the word anniversary wrong. There should be 2 letters N in it. But I've never told him, so don't tell him. And my area of chemistry, the one I'm working in now, is so-called green chemistry, which are cleaner ways of making chemicals and materials. And particularly, I've been working in the area of cleaner solvents, the solvents that we use for carrying out chemical reactions. And on the wall in my office, there's a photograph here of a model that was made in 1869, the same year as the periodic table, to explain what are so-called supercritical fluids, which in this case, for my work, has been highly compressed carbon dioxide or steam, which can be used as a solvent for chemical reactions. And I used to have a demonstration in my lab, in my office, but which has now been moved because there isn't room, but I can show you this video of it. It had a little cell which contained a liquid and a gas above it. And if you start heating it, you can imagine the liquid begins to boil. So material goes from the liquid to the gas, and the gas becomes denser because it can't get out. And the liquid expands because it's being heated, and eventually the line disappears and you have this so-called supercritical fluid. And if you cool it down again, it separates with this storm, which I think is really beautiful. And I used to keep this in my office because if somebody said they were interested working with me, I would show them this. And if they went, wow, I would know they were a suitable person to work with me. And if they looked bored, I would tell them to go and work with somebody else. And we studied a reaction, which we're in fact still studying, which is called supercritical hydrogenation. This is adding hydrogen to organic compounds. And what we were doing is taking a substrate, an organic compound, reacting it with hydrogen in supercritical CO2, mixing them together, passing it over a catalyst, the reactant, the substrate turns to product, you release the pressure, the CO2 goes this way, the product goes that way. And on the wall is an invitation to the reception to mark the opening of the world's first supercritical fluid reaction plant. And here is the plant that we built together with a company called Thomas Swan & Co., which could make product on the scale of 1,000 tons a year. So this is the reactor here, and here is a worker on the same scale. And for those of you of chemists, this is the actual reaction we did. But more importantly, this is a photo of the first bottle of product that was made. And you can see it says batch 1. And I was really excited. I sat in my office holding this bottle. And then the student came and said they needed the chemical, and I've never seen the bottle again. So I think it must have been thrown away. So I now you had a lecture just now about maths. And I wanted to talk to you about periodic table as a graph. So if you think about simple maths that you learned at school, you have a line going up here and things increase on the x-axis and on the y-axis. But if you look at the periodic table, things increase as you go on the x-axis. Hydrogen is lighter than helium, so the weight goes up. But if you go in this direction, you can see the numbers go down and it decreases. So one day I was just playing on my computer and I wondered if we could change the periodic table, because this periodic table is very difficult to teach students how the electrons fill up in the elements. Because usually when something fills up, when you're pouring water into a glass, it fills from the bottom. But on the periodic table, the number of electrons fills from the top. And people are not used to things filling from the top. So we have complicated diagrams like this to try and explain how the electrons fill up. It's called in German, by the German name, the Aufbau principle, the building up principle. So I wondered whether we could turn the periodic table upside down, because then you see the electrons would fill up from the bottom. And once I printed this, I got really excited. I thought it looked really good. And so I wrote an article for a journal and sent it to them saying my new idea of this periodic table. And the editor wrote back and said, but people are used to reading things, so they'll begin at the top and not look at the important elements near the bottom. But then I remembered that my daughter, who is a psychologist, specializes in what is called eye tracking. She can study what you're looking at on a screen. So she produced what are called heat maps to show how people look at the periodic table. And at the top is the normal periodic table, and people begin by looking in the middle here, and then their eyes go to the top. And with the other periodic, the upside down one, they still look in the middle, but then their eyes go to the bottom. So the editor was persuaded, and we published an article with, I was really proud with my daughter, which you can see the first author is Polyakov and the last author is Polyakov. And it is the only time that the journal Nature Chemistry has published a paper in dealing with experimental psychology. And this periodic table has excited some people. It's excited me. I have one upside down in my office here on the wall. And then there was a mobile science exhibition, which here you can see was in this city here. I don't know how you pronounce it, Suruga city. And if you look on the wall at the back, there is the periodic table of the abundance of the elements, and there is the upside down periodic table of ours. And then for the closing ceremony of the International Year of the Periodic Table in Tokyo in December 2019, people were given a periodic table fan, but with our upside down periodic table on it. So I was really excited. So as our chair explained, we have been putting chemistry onto YouTube. And 15 years ago, in 2008, during 5 weeks, we worked with a filmmaker, Brady Harron, to make a periodic table of videos. So, and now 15 years later, we're still making new videos. So the idea is you have a periodic table, you can click on any of the elements, and then you get a video about the element. For example, here's hydrogen exploding. This was such a big explosion, we had to do it outside because it was too big to do inside. And at the moment, we have over 280 million views, including Hiria Chair. And at the moment, there are 712 videos but there will be another new video, I hope, by this time next week. And it has been really good for me. It has enabled me to meet what I would describe as the superheroes of the periodic table. This is Yuri Ganesyan, Brady Harron, our video collaborator, and me in Yuri's office in Dubna. And this photograph hangs on the wall in my office. Next to, you can see a Japanese good year, Happy New Year wishes. And this is a souvenir mug that I got from Dubna. But what is nice is that young people come to visit Nottingham, often from quite large distances. And this is Eduardo Bandieri, whose parents brought him from Italy specially to Nottingham as his 10th birthday present. And here he is looking at liquid nitrogen. And here he is with me, giving me a card. And then a few years later, in 2019, I got a message from Eduardo saying, "Do you remember me? I'm now almost 17 and I studied chemistry in high school, and currently I'm having a summer job in a lab. Me and my teammates got qualified in 3rd place in the National Scientific Olympiad, and I had the highest score in Italy for chemistry. I still love your videos that were life-changing for me. I hope that you and your team will never stop making them." And then 2 days ago, on the 10th of August, I got a present from another fan, Hugo, who's age 12. Here's a picture of Hugo there. And he sent me an Indonesian periodic table. So I was really excited. It's still in my room here because I haven't yet been to my office to hang it up, but you can see. So now there will be an Indonesian periodic table in my office too. It should be said that this periodic table has shown which elements are gases, liquids, and so on by the color. So the pink is the gas, orange is a liquid, and yellow are the synthetic elements or artificial elements, as they say. So this is our team of people who've made the videos. And I would particularly like to point out our technician, Neil Barnes here, who last year won an award from the Royal Society. The Royal Society is the oldest National Academy of Sciences in the world. And Neil won the first award for technicians for his outstanding work. And I wear all the time a badge which says, "I love technicians," because technicians are really important in helping science at all levels, and particularly chemistry, across the world. And I should also thank the people by name, and also those that have given money to support the making of our videos. So now I would just like to finish by showing you a short video which we made for the opening of the International Year of the Periodic Table 4 years ago. So here goes.
Are you ready? Go. Whole areas of the periodic table wouldn't be there now, and it wouldn't be periodic table that we know today.
Okay, so what we're doing today is Neil has made us some gunpowder. Oh! And I'm looking at the periodic table. Looks like an ordinary periodic table. You can take out the elements. What have we got here? Wow, chemistry. You can imagine the periodic table a bit like a family photograph. There'll be some people you know very well and others where you haven't really remembered what their name is, but you remember one or two facts about them. Lecture theatres, classrooms all over the world have periodic tables hanging in them. So you can buy vodka with Mendeleev's name on it.
Actually produce and show you elemental fluorine.
I've never seen so much gold. In fact, I've never seen so much of any element.
Inserted the cube into the periodic table of the elements.
For the chemist, I'd like to get in my tie. I'm in India. I'm on the train going up the Corcovado mountain in Rio de Janeiro.
Nice sunny weather in Stockholm. So, oh wow.
I'm on Bondi Beach in Sydney, Australia. So we're in Darmstadt in Germany, where they made 6 different super heavy elements. And I'm just going to show you how they did it.
We're trying to make literal Amharic translation, so the Ethiopian translation.
This is Mendeleev's business card. And you can see it's a fan. I've been told that they need to take one of my hairs. Ooh. So each element or each symbol is 4 microns across. Everything is revealed.
4, 3, 2, 1. Oh, lovely.
And I'm in the office of Yuri Aganesian, after whom element 118 was named.
A barking dog sound, a woof sound. So once again, I've managed to decimate the equipment.
After this, whenever he was lecturing the reaction, he would hold up his hand and say, I had a hand in that reaction.
So a chap called Kip actually invented this back in the 1800s.
And here, I also found my very first periodic table.
So thank you very much. Please ask me some questions.
Okay, thank you so much, Professor Martin, for interesting talk. It's actually quite unusual presentation because you saw, I don't know how to say, like the magical of periodic table or including the history of periodic table. And I just realized that you are a big fan of periodic table. So many
Yes.
collection of the periodic table on your office. Okay, I would like to invite all the participants if you have any question. Okay, question from Lisa Listiana. So please.
Okay, thank you. Sir Martin, thank you for your inspiring presentation. Through your presentation, we can see that how much your love for periodic table. I just want to ask your opinion. So, in your opinion, do you think that by introduce periodic table in various form, such as in the form of puzzle or friend, just like you present to us, do you think that student or children will be interested more in chemistry?
I think, well, one of the things that has been really surprising is that there are a lot of children who are really quite young who get very excited about the periodic table. Outside my office, I have a really very pretty periodic table that was made for me and my colleagues by a boy who was 5.5 years old in California. I think he's now a teenager. And I think some children, particularly those who really like memorizing things and so on, find the periodic table very comforting. And I think it is really fortunate that chemistry has the periodic table, which is just like a fantastic logo for chemistry, symbol for chemistry, that most people will recognize. And it's been used for all sorts of advertising. There's even a Japanese girl music band who use the periodic table to advertise their music. I think biology perhaps has the DNA molecule, but that's not quite the same. But physics has nothing really that is the same as a sort of symbol. So please ask more questions.
Okay, thank you, Sir Martin.
Okay, any question or comment? You can ask directly to the professor or write it in the chat box. Okay, Professor Martin, maybe question from me. So
Yeah.
I watched your video, one of your video on YouTube, entitled "Your Periodic Table is Probably Wrong." Okay, so on the video, based on the paper you read, you were discussing about Lawrencium, right?
Yes.
Should be sitting on the 3A group together with scandium and yttrium, instead of putting on the very, I don't know, in the corner at the bottom, right?
Yeah.
So yeah, it's because the Lawrencium, based on the paper, is much more similar, the properties with the those elements.
Yeah.
So my question, maybe just a simple question: how to respond this paper? I mean, in the case of
I think the answer is that it doesn't really matter.
Okay.
It is very interesting. I get quite a lot of letters. I mean, perhaps 2 or 3 letters a year from people who believe they have discovered the correct periodic table or some different arrangement of the periodic table. And there are advantages and disadvantages of nearly all of them. So I think there isn't a single correct periodic table. And if you're really interested in the chemistry of Lawrencium, then it may be better to put it in one element, one group rather than another. But Lawrencium is an unstable element which can only be made in a small number of atoms synthetically. So it's really a rather theoretical question, and it doesn't matter very much. And from the point of view of your students, it doesn't make any difference at all.
Okay,
but I think the really interesting question about the periodic table is that we use the periodic table as chemists because the properties, say, of the alkali metals, sodium, potassium, rubidium, and cesium, are all related. And the question which we don't know the answer to, but which is very interesting, is when you get to the very heavy elements, do they still show the same sort of periodic behavior, or do they all behave like metals? So will element 118, a ganeson, which is in the noble gas column, will it be chemically inert like xenon or krypton, or will it be just like any other metal? And we don't know the answer to this. But I think that's a very interesting philosophical question, if you like.
Okay. Okay.
So-
Thank you. So it doesn't matter. Okay. So,
No.
so we,
Well-
we don't need to revise the current period table.
No.
Right?
And the so there are all sorts of different things. I should perhaps say, in case you're wondering, that this head behind me, can you see? There is a head just over my shoulder. So here.
What is that?
Is the death mask of Isaac Newton. It is a reproduction of the face of Isaac Newton just after he died. And we have a video about scanning his death mask. And this head was made for a BBC program, and it was then given to me after the program. So Isaac Newton has been listening to your conference.
Yeah, yeah. Thank you. Yeah. Thank you so much, Isaac Newton, for joining us. Okay. Any question from the audience? Okay, may I have a question for you again? Maybe
Yes.
this is continuing my question about Lorentzium.
Yeah.
So my point, my second question is about the use of the element for our life. So as you mentioned that our Lorentzium has a very short half-life, which is about 27 seconds, right?
Yes.
And that maybe needs to do another element. So I was wondering how important Lorentzium is. If it's only exists for 27 seconds, so is it important to our life?
Well, I mean, because it's radioactive, it would be very toxic. Well, it would be very dangerous. And so it's not really important in our lives. They could be that for some purposes, 27 seconds is quite long, because some reactions take a microsecond, and there are a lot of microseconds in 27 seconds. But so one could imagine that there might be some application for understanding some chemical problem, but for everyday life, it has no importance at all. At least I think so. You should never trust old scientists because they say things are not important and then they turn out to be important. But I find it difficult to imagine how that could be important. There has been discussion that if you went to much heavier elements, they might become more stable again, so-called island of stability. And organeson number 118 is more stable than some of the light elements just before it. But none of them are going to be of great use. If you think about it, for some of these elements like oganesson, I cannot remember, people have observed 12 atoms altogether. And in our daily lives, anything we use has millions of atoms to be any use. But on the other hand, it's always good to ask questions like yours because they make us think.
Okay, thank you so much for your response, Professor Martin. That's very nice. So what about other question?
There's one, there is a question in the chat, I think.
And no question. Oh yeah, from Pasih Bintang Ilhami. So how did Mendeleev's work lay the foundation for the development of the modern periodic table?
Well, I think the answer is that Mendeleev really was one of the people who set the modern periodic table. But there were several people who came up with a similar table, but the thing which made Mendeleev's different was that he used his table to predict some of the properties of the elements, how dense they were, what their melting points were, and he also predicted the properties of elements that didn't exist. And so his was not just a catalogue of the elements, but it was the way of really making chemistry a systematic subject. I think that many chemists now work in such small areas of chemistry that they often don't use the periodic table, but it's really important for the teaching of chemistry. So Mendeleev, although he was an enormous self-publicist, had a profound effect on the way that chemistry was taught. And he also had the advantage that he looked very striking. He had funny hair, so people remembered him. I also have funny hair, which is perhaps why people remember me. So, are there more questions?
Any feedback from Dr. Fasi? Okay, Professor Martin, maybe the time is up. Maybe one more question from me. That's probably a silly question. So what
No question is silly.
So what will you do with your collection of your periodic table? Maybe you will make a museum of periodic table or something like that?
I have no idea. I think some of my colleagues would like to put them all in the dustbin. I don't know what I will do with them, but hopefully I still have a few more years active before I have to worry about that. But it's a very good point. And so I would just like to end up with quite a serious point, which is that in my area, which is green and sustainable chemistry, that the planet is facing the most enormous challenges with climate change, feeding the population, elements that are becoming in short supply. And it's really important that we encourage young people to come to chemistry with new ideas and a determination to solve these problems. Because sadly, I'm too old to be able to solve all these problems because they can't be solved really quickly. But we need really enthusiastic people to solve these problems as soon as possible. So thank you very much from me, and thank you very much from Isaac Newton. And I hope the rest of your conference day 2 goes well as well. Thank you.
Thank you. Thank you, Professor Martin, for answering all the questions from the participants. So maybe I just want to highlight the important things of your talk. I don't know, maybe from my opinion, your video on YouTube channel, it's really important because so many elements in periodic table, actually we don't know exactly what is it and what is the application of the elements in daily life. So perhaps your video can help. So so Professor Martin, thank you so much for joining us here.
Thank
it's
you.
It's a great honor to have a discussion with you in this conference. So before we close our second session, on behalf of the committee, as an appreciation, I would like to present you, Professor Martin, a certificate of appreciation as a keynote speaker. Yeah, maybe our committee will show certificate. Yeah, this is the certificate.
Thank you.
So I hope we can send it by email or mail.
That would be very kind. Thank you. By email will be fine, and I can print it here.
Okay. Thank you so much, Professor Martin. And can I have your time? You would like to take some picture on this Zoom?
Yes.
Okay. Okay. For Anesia, could you help me to take the picture?
Okay, thank you, Dr. Heri Wijayanto. Please hold a moment that the committee will take a screenshot, and please give your best pose and best smile. We'll take a picture in 3, 2, and 1. Okay, this documentation is over. Thank you so much. I will return the session to Dr. Heri Wijayanto. Time is yours.
Okay, thank you so much, Professor Martin. Once again, thank you for your time. See you next time.
Thank you. So,
thank you, Sir Martin.
Okay, now, okay, now we are in the last session of the second session on the day 1. Thank you for all the participants, for your question, for your participation. And I will give back to the Master of Ceremony, Anesia, to handle this event.
Thank you.
Thank you, Sir Martin, to giving such informative and comprehensive presentation. And also thank you for Dr. Heri Wijayanto for hosting this session so well. Let's give them another round of applause for the excellent presentation. Ladies and gentlemen, we have come to the end of this enlightening and informative conference. I hope you all have enjoyed and benefited from the presentation and discussion of our distinguished speaker. I would also like to thank them once again for their valuable contribution and for making this conference a success. I also like to thank you for all your participation and support. Please give a big round of applause to everyone who made this possible. Don't forget to fill the absent seat. As the master of ceremony, I apologize for all the mistakes that I made during this event. Forever, we still have a day 2 parallel session to go. We don't want you to miss any part of it, so please join this conference tomorrow on 13 August 2023 at 8 o'clock Jakarta time. As we conclude to the conference, I would like to leave you with a quote by Albert Einstein. The important thing is not to stop questioning. Curiosity has its own reason to exciting. I hope this conference has sparked your curiosity and inspired you to learn more about the topic that we have in the conference today. I wish you all the best of your future endeavor and hope to see you again in our next conference. Thank you and have a great day. Wassalamualaikum warahmatullahi wabarakatuh. See you in the second day of International Conference of Mathematics, Science, and Education 2023.
Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan.
Halo, Assalamualaikum. Ya, Pak Fasih, Zaki, yang menjadi host bisa ditutup. Oh, sebentar.